that is actually not one, but actually two techniques that we are going to see. That is principal component analysis and factor analysis. Now, what will be the content of this session? So let us have a look at this, and then we'll jump into slowly the content. So first we'll see the introduction to PCA, like what do we mean by principal component analysis and why it is required. Now, from where it has come and everything that we'll touch upon. And then we'll discuss about the scaling, because scaling is one of the important part when you are doing any multivariate analysis. So we'll touch upon that scaling part. After that, we'll discuss about the factor analysis. Now, what is factor analysis and how it is decided and what is the logic behind that? Then why it is required, why we are performing factor analysis, and there are several important terminologies so that we are using in factor analysis. So that also we are going to see, and then we'll see a little bit of difference of this PCA and factor analysis. As such, both the techniques are having a common purpose, but although they are having some differences, otherwise, it is very difficult to differentiate PCA and FA in a clear-cut manner. Like this is PCA and this is factor analysis, because some of the portion with reference to its application is overlapped. Okay, so some of the portion will be overlap, and that is why sometime like whether it is PCA or FA, so that is slightly difficult to say. But yes, definitely some of the differences are there that we'll discuss upon. And six steps to perform factor analysis, because we want to perform a factor analysis, then some of the steps we have to perform. So we'll discuss these steps, importance of these steps, and along with all these steps, we'll take one example and we'll go along, performing all these things. So here, when we discuss about this PCA, at that time also we'll see one example in R that will be doing, and here also in the factor analysis also one example that we are going to see and implement. So that all will be done in a R. Now here, please note, I am not covering any of the formulas, because my intention is to deliver you the concept and how it can be applied. So if anyone is interested to know more about the formulas and all, like how it is derived and what is the logic behind that and everything, like what is the derivation and what is the mathematical formulation of it, then just let me know in the chat box. I'll suggest some of the articles and books so that you will get the detailed idea about it. And at last, we'll have a question and answer, and then we'll sum up the session. Now, we'll first touch upon the PCA part. Now, whenever we are, before I, move, I would like to ask one question. Regression or multiple linear regression concept is covered yet, or it is yet to cover?
Yes, yes,
It is covered, no?
yes.
Okay. So in that reference, I'll be talking somewhere. So you'll be able to, correlate these things. Now, why we are using multivariate analysis? Now, regression, and then it may be a cluster analysis, it may be a discriminant analysis and all. So the purpose of the multivariate analysis is to study the population characteristics. Okay, so I'm highlighting some of the things which is important in this definition. So we want to study the population characteristics using a possible information on the sample. Okay, so let's say this is our population, and from that we'll take a sample. Now for this one sample, like for example, I've selected this 50 people. Now for this 50 people, I'll be collecting some information like their age, weight, height, their hobby, their income, their education, and many more. Okay, so that kind of information I'll be collecting for this 50 people, and I'll be analyzing this data of 50 people, and then I'll make some inference about my population. Then, based on this sample, we can say the average age of this population is so and so. Minimum age of this population would be so and so. So likewise, we are making an inference about this population. Now, this set is collected from each individual. So here I have collected this age, weight, height, education, income, everything is from every individual. So it is, expected that they will be correlated. So for example, if you are collecting my height and my weight, And if you perform correlation analysis, then you will definitely find a correlation between them, because it is taken from a single individual. So likewise, almost our all observations are like that only, that this is, let's say, person one, and in the columns we are having some variable. Okay, so this is variable one, variable two, variable three, variable four, likewise that. And then person two, person three, likewise we are having 50 people. Okay, now what I'm trying to say by this point is that this variable and this variable, since it is from this like same person, so they might be correlated. Okay, now when it is correlated, at that time, shall we keep both the variable in our model? Let's say if they are correlated, then shall we keep both the variable in our model? In the multiple linear regression, you might have understood the concept of multi-collinearity.
No, sir.
Yeah, that's true, very true. We should not take, right? So let's say anyway they are correlated, so if any of the variable if I keep, then it will serve my purpose. Okay,
Sir,
so this,
one
yeah,
question.
yeah.
Sir, I think whenever we talked about multicollinearity, it is the basically depth of the multicollinearity. Suppose the correlation is very small, then I think there is no problem, because in most of the regression analysis there is a correlation always in the between the variables, right? In the
Right,
independent variables. So
right.
if the correlation is small, then it is, I think, okay. There is no, if we check with VIF and it is okay, then there
Yeah,
is, I think, no problem.
that's very true, very true. So, and that is why, like, this correlation is small and correlation is medium and correlation is large. So that is all subjective actually. Now to make it objective, like, it should be correlated. If you are, seeing at the picture, then also it is correlated. And if I'm seeing that example, then also it should be, the same result. So that is why there is a concept of VIF, variance inflation factor. And by looking at this value, we can, take a decision whether to, keep this or remove this. That is very true. Okay. Now here, many of the time what happen, we can't remove any of the variable, but we want to, keep information from all the variable, so that importance can be as it is. Now in those situations, this principal component analysis will be useful. So now let me just, go into the detail of 2 3 slides, then you'll have the idea. Now as a practical problem, when so many information about one particular person or product or process or event is calculated, or it is measured, at that time it is very difficult to analyze all the variables. Okay, and now I'll give you a practical example. I visited one chemical industry. In that, they are collecting every 5 minutes a data. So let's say 0, 0, 5, and then 10, 15. Likewise, they are collecting a data. Here their yield is there. Y is a yield of the process. And then they are having x1, x2, x3. Now it may be a process parameter like temperature, pressure, speed, chemical composition, and many more. So you won't believe there are 576. Okay, 576 variables are there. Now, do you think 576 variable I can draw a regression analysis on this? Why? How much complex model it will, right? So 576 variable, and here observation, how many it would be in a day? So every 5 minutes of interval, so that you divide by this one, then you'll get like 300, 400, this one, like, so around 300 observation you will be getting, and it is double than that. Now it is not, necessary to keep all this 576 variable into this, but now which to remove or which to, keep. So in that case, this PCA will help us to decide that. So basically, as a researcher or as a problem solver, what we have to do? So we have to identify some of the important variables, okay, which can explain the almost all the variability in the data. Okay, so if we can, if there is some background is very strong about that area, and technically we are very much sure that these are only the variable we should keep, then that is one way of, reducing that. Okay, otherwise we have to use some of the techniques. Now at the early stage of scientific investigation, there was a little theory that, how to select this important variable which are suitable for explain most of the variability in the data set, and we can go for the multivariate technique. Now that was there, but after that, that technique has been developed, and that is PCA, that is just we are discussing now. Now we need some data reduction technique. Okay, so data reduction technique that we have to use, and that can systematically summarize this. Now it should not be like that. Okay, I don't like this x5 to let's say x15. But just remove those variable and keep all other things variable, right? All other things in a model. Or I can't say like based on my experience, because I'm having let's say 10 years of experience. Based on my experience, I'm telling that you should only keep this one. Okay, now that is only based on this 10 years of experience. Now it may be possible that during this 10 year I have not observed some of the things, and that I will miss it. Okay, so these are the chances. So to overcome all these things, we need some technique which can systematically do this thing. So there has not to be any bias or something like that. Now here, when the person is saying that I am experienced person, and you remove all this variable, then it is a bias. It may be bias thing, because it is given by some person, and if you ask to another person, then opinion will be different. Okay, and now there is a technique which can help us to reduce the number of columns. That is, column means the variables from the original data, and maintain as much of original information as possible, and that is known as a PCA, principal component analysis. Now this reduction in the number of variable is helpful to comprehensive idea about the population during further research, because ultimately where we are going to use it in a multivariate analysis. So in that, this reduced number of variable will be helpful, and that will make our model simple instead of complex. Now what this PCA does? So PCA is a technique which finds a few linear combinations. Now linear combinations, I'll just talk about that in the next slide. So linear combinations of original variable. Okay, now how it is related? So some of the variables are moving in the same direction. Okay, like x1 and x2, they are moving in the same direction, and let's say x3 and x4, they are moving in anti direction, for example. So likewise, basically it tries to find out the linear combination of all the original variables, and based on that it summarizes the data, and it tries to lose as little information as possible. So it's try to retain maximum information about the original set. Now it will also tell you that how much you should go for the reduction. And let's say if you reduce up to this level, let's say there are uh, 50 variables in original set, and if you go for let's say only 3 variables, now this is not called variable, actually this is known as a component. So if you reduce from 50 to this 3, then you will be able to get let's say 70% of the information from this original data. Now you may say that no, this 70% is not good enough for me, so I need at least 85%. Okay, then you should increase this one, so you can go for 4 or 5. So that individual component, how much variation it is explaining, that is also suggested by this PCA, and based on that you can select the number of component to be kept. Now basically this linear combination, let me focus on this word, which is linear combination. How it is done? So it is basically a weighted average. Okay, yes,
Presentation detail is not coming.
sorry.
Presentation. Okay, now it is okay.
Is it visible now, sir?
Yes, sir. Yes.
Okay, okay. So now what do we mean, how these linear combinations are decided? So basically there is a logic of weighted average that is given to this variable, and then accordingly its direction and its loading and everything is decided. Now please excuse me for 10 minutes while if you are not getting this one, because after 10 minutes when we jump into the example, at that time you'll be able to visualize all these things. So this basic part is important, and that is why I have included this one. Now this linear combinations, that is what we are deriving from that analysis, that is known as a principal components. So how many components are possible. So it is equivalent to the number of variables. So for example, your variable are 50, then maximum 50 components you can make. Now this one component will have, let's say, some of the weightage from variable 1, 2, 3, 4. So from this each 50 variable, there will be some weightage in this component 1. And then in component 2 also, there will be some weightage from this 50 variable. So it is studied like how each of the variable is contributing to each of the component. So likewise it is done, and from that it is arranged something like that, that maximum variation will be there in the first component, and then the second maximum variation will be there in the second component, and then third, and then fourth, and so on. Now if you look at the visual picture of the PCA, then it would be something like that, and here the equation of the linear combination is shown. So for example, here this is age, this is height, this is weight, this is, let's say, income, something like that it is there. Now basically, the weight will be decided. Now there is some formulas for that to decide the weights and everything. Everything is scientific. So weight will be decided, and based on this weight, one component will be formed. So this is C1, for example. Now similarly, there will be another component, okay, and there also this y1, y2, y3, y4, that will be there, and their weightage will be there. Now here, whatever weightage of this y1, that will be in a component 1, that will be maximum. Okay, so here in the component 1, it will have the maximum one, and then it will go and reduce that one. So it will be in a descending order. So we can easily find out that how many components to be kept. Yeah. So and the formula for that would be like how this component is built. So C is equal to W1 Y1, that is weight 1, into that information about that variable, W2 Y2, that is information about this, W3 Y3, that is information about this, and W4 Y4. So likewise, if we are having Y50, then this model will be in that way. Now this is just a basic idea about the PCA, but here one thing is there, like here we are talking about the age. Now age is measured in a year, okay, and there will be only 2 digits. Here height is there, which is measured in a centimeter, and that will be in a 3 digit. Here weight is measured in a kg, and that is also will have, let's say, a 2 digit or 3 digit. Income, that is measured in, let's say, in terms of rupees, and that is having 5, 6, and 7 digit, for example. Now all these are at the different scale. Okay, now how these weights and all everything will be decided, that will be decided based on the, let's say, Euclidean distance or some of the geometrical distance. So how it will be done, so it is basically measured on this kind of graph, and how much this particular point is away from this particular point. So this is how in a backend it will be deciding like this. Okay, so that is Euclidean distance, or some other like Manhattan distance, and there are several methods which can be used to find out the difference between these 2 points, like distance between these 2 points. Now here, if this point is in 1000 and this point is in, let's say, like age in years, 20 years, right? So now it is very difficult to quantify this one, and there is third variable which is, let's say, in a centimeter, okay, that height. So it's very clumsy, or you can say it is very disturbing. And whichever variable which is high in nature, so here 1000 is high, right? So it is in, let's say, 5, 6 digit, okay, so it will be dominating other distances. So here it will be definitely more compared to this one. Now by 20 years, and here let's say 150 centimeter, that difference will be small compared to this one. But let's say in real situation, it might not be the case, which is creating the weight. So now to overcome this challenge, what we have to do, we have to go for the scaling. So before performing this PCA, we have to use scaling technique. Now the scaling techniques, there are several techniques. Out of that, we are going to discuss 2 techniques. Now, first of all, what is scale? The scale is something how something is measured, right? So scale is how something is measured. I mean, practical life, we measured something in, some different information on a different scale, like age in years, height in, let's say, centimeter, weight in kg, let's say IQ level or intelligence, or it may be a, beauty, then it is in a 5-point scale. So all are different in nature. Now, whenever we are collecting this information from the same person and we are using it for the PCA, at that time it will create a problem. Now, no, it is not only applicable for PCA. In majority of the technique, I am showing you that, like while using statistical technique on the data, if scale is different, it's become difficult to interpret and sometimes it will mislead the result. And that is why the scaling is important, because many statistical techniques, they are using Euclidean distance or similar geometry measure for the calculation. Now, at the time of that calculation, which variable is having the higher value in scale, for example, thousands, right? So that will dominate the variable, compared to the lower value scale. So it will dominating to the centimeter or the age or let's say weight or something like that. So here the example is given, like this is 1 lakh rupees and here it is 24 points. So obviously the experience is here 8 years. So it will dominating the distance and the calculation. So that actually we don't want. It should be on an equal basis. Then only we can get the right weightage. Now the question is, scaling is always required, or we need to do it sometime only? So it is not always needed. Okay. Now when to use it? So some of the models can effectively handle the different scale. Okay, now what are those models? So let's say if you are using a decision tree model or let's say random forest model. So in that case, they are not using in a backend Euclidean distance or any other distance. It is actually working on the real values. So that is why in that case, if you don't go for the scaling, then it is also perfectly fine. Okay, another thing, you have collected, let's say, data on 5-point scale, 7-point scale, 10-point scale, and all your variable like variable 1, variable 2, and up to variable 50, all are measured on the same scale, like 5-point scaling or 7-point scaling or 10-point scaling. Then you don't need to change that because everything is in the same scale, so you don't need to worry about it. Okay. Now, many models need scaling. Now, what are those models? So it may be a support vector machine, it may be a k nearest neighbor or logistic regression or clustering method. In that clustering method, it may be a k-means clustering, hierarchical clustering, or let's say feature extraction method, that is PCA, principal component analysis, linear discriminant analysis. In all those things, this scaling is required because it is using the some of the geometrical logic behind it. Now, if you look at the type of scaling, then there are mainly two types. There may be other types, but mainly two types which is very much popular. One is known as a normalization, and that is also known as a mean max transformation. Okay, and another one is standardization. So there are two different words: normalization and standardization. Now here, when we talk about the standardization, at that time it is z-score transformation. So there are two transformations that we can apply. Now, what is the difference between them and how it is calculated? So let us have a look at it. So let's say any of the value you may be having that in a lakhs, or let's say in a crore, or it may be in 1,000, or it may be in numbers. Now, if you apply this formula, then it will convert your data set between 0 to 1. Okay, so here let's say we have to find out the minimum value. So age is there, right? So age is given, some of the values like 15, 20, 30, likewise it is there. We have to find out the minimum. So let's say minimum is 10, maximum is, let's say, 30. Okay, and we have to apply this one in this formula. So to find out the transformed value for this 15, what we have to do? 15 minus minimum is 10 divided by this 30 minus 10. Okay, so it would be 5 minus 20. So this is how it will be derived. Now if you correct this formula, then we'll get the normalized value for this particular observation. Likewise, you have to find out for this, for this, for this. Now see, here I'm just showing you the manually. Otherwise in Excel, or it may be in R, You can just, by putting this formula, you can calculate for the entire column. So this is one way of, normalizing your data when the scales are different. Now there is another one that is called z-score transformation. So z-score measures the dispersion of the data basically, and technically z-score tells you the value of x is how many standard deviations below or above population mean. So if normal distribution is covered, I suppose, in any of the session, then you might be able to correlate that, in the normal distribution, the values are something like this. Mu plus or minus 1 sigma, it is covering 68% of the observation. Mu plus or minus 2 sigma, then it is 95%, and plus or minus 3 sigma, then it is 99.7% of the observation it is covering. Now what this z-score will tell you, that how much standard deviation, if value is falling somewhere here, so it is minus 1.5. Okay, so that will be the value of your z-score value. If your value is falling somewhere here, then it is plus 1.5. So it will tell you about that. And if your value of this z-score is positive, you can say it is higher side of the mean. And if it is less than this, if it is negative, then you can say it is a left side of the, or less than your mean. That is what we can interpret from the z-score value. Now how it is done? So there is a formula. Now which one is the formula? So let me show you. This is the formula. So to find out this, you need to have, let's say, this value of mu. Mu is nothing but the mean and the standard deviation. Okay, so now let us see the example of both the transformation in the same data. So here I am having two information here, and the actual values are given. So here engine size is given 1.8, 3.2, 3.5, 1.8. Likewise, it is given 10 observations are there, and here horsepower is given. So horsepower is in HP, that is 140, 225, 210, 150, 200, 310. Likewise, it is given. Both are having different scale. Now we have performed this min-max transformation as well as z-score transformation in both the cases. So now let us try to understand this. So here in this case, the minimum value is 1.8 and maximum is 4.2. Now here, if you look at the min-max transformation, then minimum value is this one. Against that, what is the value of standardization? So it is 0. And if you look at this one, this 4.2, that is the maximum value. So it is 1. So what it has done, minimum value will be given as a 0 and maximum value will be given as a 1. And then you can see all other values are relatively transformed. So all the values are between this 0 and 1. And here, if you look at the horsepower, here it was in, let's say, 1 decimal, and here there is no decimal, but there are 3 digits. Now, if you look at the value of this, this horsepower, when we perform this normalization, at that time you can see the minimum value is 140 and maximum value is 310. So here you can see this is the minimum one and this is maximum one. Okay. So now both these are on the same scale, 0 to 1. So whenever you are performing any of this distance and everything, at that time it will not create that problem of dominating some other variables. So that is one way of transforming it. Another way is, let me show you this one. So here z-score transformation on the same data has been applied. Now what it has done, it will be using the min-max, not min-max, but mean and standard deviation. So z is equal to x minus mu divided by sigma. So here I have found out this values. Now how it will be done? So for example, this 1.8. So if you put this 1.8 minus, what is the average of this? So that is 2.85 divided by standard deviation of 0.69. If you correct this formula, then you will get this minus 1.52. Okay. And go along with this all observation, you will get all these values. Now whenever you get your z-score value near to the 0, so here you can see this is near to the 0, this value, even this value and this value, then you can see this value will be nearer to the average, because 0 is nothing but your average value in the normal distribution. So here our mean value is what it is coming 2.85, and here also you can see 2.8, 2.8, 2.8 it is coming. Okay. And if you look at this, horsepower value, then also it is converted into that same scale. So now if we use this one for our, further analysis, then it will be right manner to use it, and it will not create a problem of, let's say, dominating some other variables. Now you might have a question that when to use this one and when to use this one. Okay, so ideally you can use any of this one. Let me see if I have not, no, I have not included that one. But let me tell you one major difference is, like, mean max transformation is not robust against the outlier. Okay, and this z-score is said to be a robust against the outlier. So whenever outliers are there in the data, at that time you can use z-score transformation, and whenever further statistical analysis is required, this z-score will be preferable compared to this one. Okay, so that is the difference between this min max and z-score transformation. So basically min max will convert your data between 0 to 1 scale, and this z-score transformation will convert your data between mu plus or minus 3 sigma. So in that way it will be calculated. Now here, like how it is, robust against the outlier. So if this value is coming to, let's say, 4 or 5, okay, so in this case it may be possible, it may be -5 or it may be 5. So at that time easily you can, identify, okay, this is plus, beyond plus or minus 3 sigma limit, because 5 sigma limit mein ja raha hai. So it is creating an extreme position in the distribution. So immediately you can identify. But here everything will be between 0 to 1 only. So it will never go beyond this 1. So it is difficult to identify those variables. So that is why z-score is preferable. And in our example also we'll use this z-score transformation. Yes, so that was the case of scaling. So what we have learned till now, we have discussed about the introduction to PCA, why it is required, and what is the basic logic behind that, and what is this concept of scaling. So in that we have learned this min max transformation and the z-score transformation. Now we are going to
Sir,
yes, madam.
yeah, I have a, actually doubt. Within the factor analysis, there are two form, I think, that exploratory and that confirmatory.
Yes, in factor analysis there are two ways. Like, one is exploratory factor analysis and another one is confirmatory
Right.
factor analysis. So I'll touch upon this two part, because currently we will be doing exploratory data, this factor analysis. So when we'll come to the factor analysis, I'll tell you about the difference between these two.
Okay, sir. Fine, fine.
Yeah, yeah. Now we want to perform, let's say, PCA in R. Now there are, when we using this R, so I'm just, now onwards I'm talking with reference to R. So basically there are two methods to perform PCA in R. The first one is called spectral decomposition, which examines the covariance and correlation between the variable, and another one is singular value decomposition. So these two methods are there. Okay, now it is also short form, it is known as a SVD. Now to perform this, functions are quite easy. That is print comp, and into bracket whatever the value or the data set we have to provide, and another one is PRCOMP. Okay, and if you are using some packages, then factor min R, that package is there, in that PCA is there. So if you use that also, then also it is using the singular value decomposition. So basically this PRComp, that is using this SVD, that is singular value decomposition, and print comp, that is using this spectral decomposition in the R. Okay, now according to R help, now this is I have taken from there this thing. So if you want to understand this in more detail, like what is the spectral and the singular value decomposition, you may further get down into that, because I am also this is like an ocean. So each and every time when you perform all these things, you study some of the help, you study some of the different models. At that time some of the things comes in front of you, so you always keep on learning, keep on learning, keep on learning, kind of that. So now from where I have got this information, so it is mentioned in the R help. There's SVD, that is singular value decomposition, has slightly better numerical accuracy. So but this PR comp is preferred compared to this print comp. Okay, because these are the two approaches of the decomposition. Decomposition means how this particular variable is decomposed and its weight is decided. So now these are the two methods. So out of that SVD, that is singular value decomposition, if you are using, then it will have more numerical accuracy, and ultimately we aim for more accuracy. So we'll use this PR comp, and we'll also, just if time permits, then I'll also show you this one, that what is the difference that we are getting when using this one. And here, whenever you are, using this PR comp or print comp, two functions, right? So this is some SVD that we are aiming. Now, when you run this, at that time, these are the calculations are done in a backend, that is SDEV, that is the standard deviation of the principal component. And here also you'll get the same thing, that is SDEV, and that is the standard deviation of the principal component. Here it is telling about the rotation. Rotation means nothing but the weights or the loading. Okay, so here in this analysis, the terminology is loadings. Here in this, it is rotation, but ultimately it is a matrix of variable loadings. That is, columns are eigenvalues. You can say these are nothing but the eigenvalues, and it is showing you the weightage of that particular one. But terminology is different. Here it is known as a rotation. Here it is known as a loading. Another one is center, and here also it is called as a center. So the variable means the means of the variable, you can say. So for example, v1, v2, v3 are there. So what is the average of this? That is said to be a center of that variable. And then scale is there. Okay, scale is nothing but the variable standard deviation. Now here SDEV hai, that is the standard deviation of principal component, and here this is the standard deviation of variable itself. Okay, and here it is known as a X, or here it is known as a score. But what is the meaning of that? The coordinate of the individual observation on the principal component, that how each variable is, let's say, coordinating with this, let's say, principal component 1, PC2, PC3, and here v2, v3, like variables are there, how much it is coordinating on that particular component. So here it will be shown as a X, here it will be shown as a score. Now we are going
Sir,
to, yeah,
one question about the decomposition. So the decomposition basically means that how the variables are allocated in different components.
right. So that is called decomposition, and there are two ways to do that decomposition. So one is spectral and another one is singular value. So there are
So
two
that means
methods given in R.
that means in one we are checking the correlations what are the correlations between the variables, and
Yeah,
another one within the variable what is the correlation among the individuals. This
yes,
is the
yes,
main difference. Okay,
yes, yes.
okay.
Now, up to this, we were talking about theory and all these things. Now, let us see one practical example. So, in automotive industry group keeps a track of sales of the variety of the personal motor vehicle, that is car. In an effort to be able to identify over and underperforming models, we are having some features, right? So the features are like their price, their engine size, their horsepower, that is wheelbase, weight, length, curb weight, fuel capacity, and then fuel efficiency. So all these variables are given, and based on that, we would like to find out the some of the groups, or let's say some of the components which will be we can reduce, because when we go for the model building to use all this thing, it will become a complex thing, because whenever we are using it in a practical life, at that time, even to collect a single information, you are spending money behind that. So many of the time we feel that why to reduce this, let all this will be in the model, and then we can check that. If it is not important, then we'll remove that. That might be first but thought of our mind. But whenever you are keeping, let's say, this price, then there are 500 people. For that you are collecting 500 information, and let's say if it is taking some time, x time, then you can see how much time it is, taking in collecting the information, in entering the information, in perform like computation of that information. So it's very difficult, and that is why if we can reduce the dimensionality of it, then it will be helpful for us, and it will save our computational efforts. Now here the file is given to you. Let me share that one so you can also perform along with me. So I'm posting that material in the chat box. Please download that, and then I'll just ask you to perform along with me. So whatever I'm performing, that I put over there in the material. And once it is done, please mention done in the chat box. So in that material, the presentation which I'm using, as well as the file that I'm using, that will be there. Okay, I'll wait for 1 more minute because I'm saving only few done. So let me wait for 1 more minute, and then we'll move ahead.
So meanwhile, may I ask a question to you?
Yeah, please, madam.
Sir, you were saying that the principal component has to be a weighted linear combination of the various variables, right?
Right.
So does it necessarily have to be like linearly linear combination, or it can be non-linear combination as well?
In this, basically, when you use this principal component, at that time, whatever in a backend it is working, that is considering that linear combination will be prepared. Actually, we are not giving a linear combination, but it will prepare a linear combination. Whatever data you'll give, it will prepare a linear combination of those variables. So that
Okay,
is
so
what
it is
yeah.
inbuilt. So it is
Yeah.
inbuilt of there. Okay.
Yeah, it is inbuilt kind of thing. So when you give your data, so as we are just giving this raw data, it will find out the linear combination of it. Now if let's say in data there is a non-linear relationship, then we have to study it, and we have to overcome this thing.
Okay, fine, sir. Sir, and one more thing, you were saying that it is a data reduction technique, right?
Yes.
Yeah. So can it
Actually not data reduction, but actually it is a dimension reduction.
or can it also be alternatively? Can it also be called a factor reduction technique? Or it is applicable? That word is already applicable in the case of factor analysis, sir.
Actually, there is very less differences between principal component and this factor analysis. So
Yes,
when you want to perform this factor analysis, at that time you have two logics. Like in factor, we are extracting the factor out of this variable. Here we are extracting the components out of this variable. Now, how many factors to be decided? So in that is always a question, that how many factors we should extract, so that we can know from this principal component logic. So when we want to perform this factor analysis, at that time there are two, or there are 4 or 5 methods, different methods are there, that we can use to give a logic that based on this we are going to do let's say factor extraction.
Okay, so, and final query, sir. One more
Yeah,
final
yeah,
query.
yeah.
The thing, suppose there are four variables, right?
Right.
And suppose how many components can we make out of it? So the entire,
Four.
so four variables, four principal component,
Yeah, so that
PC1,
is the
PC2.
that is the maximum it will give you. So
Okay, sir.
whenever you perform this principal component analysis, at that time it will create a number of components which is equivalent to the number of variables. So if four variable are there, it will give you the four component. But how this component will be done? So in first component, maximum portion, like 70% of the variation will be explained by this first component only. Let's say 20% of the information will be explained by the second variable, the second component only. So if you take just first and second component, then it will be explaining 90% variation out of the this four variable.
Okay, so the question what I was asking you is the four variables. Suppose age, weight, income, height. Okay, so these are the four variables, and we made the system will give me four components: PC1, PC2, PC3, PC4. Right,
Yes,
and
yes,
all these principal component, these four principal components will have these four variables, but the weightage of each variable in each of the principal component that I have derived will be different. So that's how it will explain the variability in the data set. That's what you're
exactly,
trying to say?
exactly. Yes, exactly. In PC1, there will be a weightage of overfold this age, height, weight, and everything. In PC2
Mm.
also there will be a weight. But in the first component, maximum weight will be loaded. So that basically, it will create a score, like component score or loading. We can tell it.
So
So
we
that
have heard
loading
about,
will be
I have
calculated.
factor loadings are also there. I have heard
Yeah,
somewhere
so that
factor.
will be, yeah, in factor analysis, factor loading will be there. In principal
Okay.
component analysis, this component loading will be there. But it is the
Oh,
same thing. The backend formula is a little bit different. Otherwise, it is the same thing.
yes. So actually, it's very confusing. That's why I'm clearing out the
No,
issues
no,
with
no.
you.
Yes, absolutely right. And
Yeah.
when I was learning all these things, and still I'm learning. I'm not saying that
Yes,
I'm
sir.
expert in this one. Still I'm learning. But at that time, similar question I also used to get in my mind, and I used
Mm.
to read some of the books and all, so that I
Yes,
have
sir.
got some of idea.
I've been learning this PCA since 2016, since the onset of my PhD. So I don't know. So it always get confused whenever a new resource person comes up with this topic again and again. So it
Okay,
gets confused, like, PCA, then factor
okay.
analysis, then discriminant analysis. Like, where does it like?
Okay, okay.
Okay,
I'll,
thank you
I'll,
so
I'll
much.
try. So, जितना मेरा knowledge है, I'll try to
No, no,
give you
सच
the answer.
आपका देख तो आज मुझे बहुत clearly समझ में आ रहा है. You are so that I liked about it. Your presentation, clarity and simplicity. How simply you explain the things.
Yeah,
So
thank you,
I'm
ma'am.
asking you.
Yeah,
Thank you so much, sir. Okay.
thank you, ma'am.
As of now,
Yeah,
I'm done, sir, with my queries.
yeah, yeah. Okay, okay, ma'am.
Excuse me, sir,
Uh,
may I have a question, please?
yeah, please, ma'am.
Principal component analysis is also done in eViews. So, which one is better one? In
Uh,
eViews package also, it is also done. Will you please
Views is a
just?
software, I suppose, no?
Yes, yes.
Okay. Actually, these are all the different software. So, see, I am using it in SPSS also. I'm using it in
Mhm.
R also. I'm using it in a Python also. So
Okay,
ultimately,
sir.
backend logic is in all the software will be same. So there won't be any problem if you are using any of the software. Even if you, let's say, you are clear with the formula of it, then you go and manually you can also calculate and match with the software. Then also you'll get the same result.
Okay,
Yeah,
okay, okay.
minor difference may be there. Minor difference is what, like sometimes this degrees of freedom, that concept is there, like n-1. So in some of the places they are not subtracting this one, so slightly different will be there. Baki almost same aayega aapka.
Okay, sir. Okay, sir.
Yeah,
Thank you, sir. And
thank
thank
you,
you,
ma'am.
sir. And another question, sir. There is the correspondence analysis is that can be done in our software.
Mm, I don't know about the correspondence analysis, so can you just tell something more
Actually,
about it?
I searched about it in net many
Okay.
a times, but they are not giving that. That they actually I don't didn't get it. That is why I'm asking you, because
Okay,
I
okay.
need it.
If possible, madam,
Okay.
I would suggest you, I'll share my contact number. You just, share me like some detail about the correspondence analysis. Then I'll check whether it is, we can perform this in R or not. And if it is
Sure,
performed
sure,
in
sure.
R, in what package we have to install, that also I'll tell you.
Sir,
Okay.
is it, Arundhati ma'am, is it corresponding analysis is a geometric approach for visualization row and columns?
Yes, 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 you're right.
Okay.
I've done in
So
SPSS.
already packages available in our.
Hmm.
Yes, yes.
Okay, it is
So,
available.
so as far as my knowledge is concerned, so whatever is possible in SPSS, I think that all thing we can do it in R.
Hmm.
So as far as whatever tools and techniques I have used, but anyway, but just give me a brief case of it, then I'll just search into it, and then it will be also my knowledge enhancement.
Okay.
Yeah,
Thank you,
thank you, ma'am.
Devaruti. Thank you, sir.
Thank you, ma'am.
Thank you.
Okay, so I hope everyone has downloaded the data. In that one file is there. So let me open that file first of all. So in that file, this information is recorded, like price, horsepower, then its curb weight, then mileage and everything. So here that information is there. So price, engine size, horsepower, wheelbase, weight, and everything is there. Now you can see here everything is in a different scale. So ideally we need to convert this into we have to normalize this or we have to standardize this. So we'll try to look at that. And when we use this PR comp, at that time inbuilt we have to just provide some argument, and then it will convert our data, or it will transform our data. So manually we are not supposed to do that. And if we want to do it manually, then also I'll show you how to do it in R. So let me open my R and then that file. So here I'm keeping this for my reference, and then again I'll be typing my this one this syntax so that you can see that how it is done. So I'm giving, let's say, name of this object is car sales, and I'm reading it from the CSV file because it is CSV file. And then I can either give a path of that file, or I can use this file dot choose. Now when I use this file dot choose, at that time it will give me the liberty to select this file from anywhere in my computer. So if I run this, it will give a pop-up like this, and then I can select that file. It is there in the session 2, and here car sales is there. Let me select that and open it. So it is done now. So please load the data like this. You can give any name like DF, data, car, anything you want to give, you can give the name of that. So once this data is loaded, you can use this head command to see like how it is looking here in the R environment. So here you can see everything is coming properly. Okay. Now, first of all, we'll see the Z-score transformation. So for that, let me show you some manual thing, because it will be helpful when you are doing research. At that time, some of the manual formulas, if you know, then it will be helpful to you. So here, I'll be performing this manually for the first column of price. Okay, so price column will take and will perform it manually, and then I'll show you in a one go how can we do that. So let's say manual Z-score transformation. Okay, now here I'm using this. Let's say I'll be first of all finding the mean of that one, because mean and standard deviation will be required. So I'm storing this mean price, and then I'm finding the mean of this. So mean into bracket this car sales dollar price. Okay, and how much value I'm getting? So I'm getting 27.338 3318. Okay, so this is I have stored, and it is the values is stored over there. I am also calculating the standard deviation. So standard deviation price, and then SD into bracket car sales dollar price. And here you can see The standard deviation is I'm getting as a 14. So these two values I have stored. So please do till this point if you want to practice along with me. And once it is done, just let me know in the chat box so that we can move ahead.
So I've given the commands car underscore sales read.csv, but nothing is coming. Actually, I gave the head also, head in brackets
Uh,
car underscore sales, but nothing is
okay.
coming. Actually, I have opened R script. Is it so, or I have to open
No,
something
it's
else?
yeah, no, in R script itself. And have you written this file.choose command?
Yes, I've written
Okay.
everything.
Now
Car
you
underscore.
just yeah. Okay.
Huh,
Whenever you are performing this operation for the first time, or let's say after
huh,
clearing the session, at that time, the pop-up
mhm.
will not be able to come in front of you. So if you see your taskbar, there something might be popping up.
Actually, I couldn't see sir, anything.
Can you share your screen?
So actually, this is the problem. I cannot share it. I'm very much new in this, and so I cannot.
No problem, madam. You do one thing.
Yeah.
Can you see the camera and microphone button over there in
That
the
I can do.
yeah?
That
So
I can.
in that last present now option is there.
So I may open the video and show you. May I show you? So I'm doing it in laptop, and I'm
Yeah, sure.
talking to you. Huh? Okay.
That's fine. Okay, okay.
So this is the command I've given.
Uh, Actually, okay. Now, if you look at the, if you please run that command actually.
Okay, sir. Okay, so now it is opening. Thank
Yeah.
you, sir.
Okay,
It
okay.
has opened.
Yeah.
Sir, I did the same thing in our
Okay,
studio.
okay.
अच्छा ये जो फाइल आपने भेजा था तो आई डाउनलोडेड द सेशन मटेरियल तो वहाँ
Yeah.
पे डेटा द फोल्डर नेम इज डेटा रिडक्शन राइट वो आ रहा है हेडर बट देन
Folder में
उसके हाँ हाँ लाइक आई डिड डिस्कार्ड अंडरस्कोर सेल्स रीड एसवी फाइल चूज तो व्हेन आई एम रनिंग इट सो आई एम गेटिंग दिस ऑप्शन व्हिच इज इन द डाउनलोड वन सो आपका वो फोल्डर था डेटा रिडक्शन राइट डेटा विजुअलाइजेशन यूजिंग आर हिरेन
no,
कक्कड़
not that one actually. I updated after that.
ओके तो उधर सर आ रहा है ग्लोबल एनवायरनमेंट में राइट साइड में आ रहा है कार सेल जीरो ऑब्जर्वेशन ऑफ वन वेरिएबल आ रहा है मेरा आई डोंट नो व्हाई
Mm, can you share your screen? I can see
ओके सर
possible. Yeah.
जस्ट अ सेकंड
I hope it is okay with everyone because I'm taking little time, but I don't want to डेटा ही लोड नहीं कर पाएंगे तो आगे वाला कुछ परफॉर्म नहीं कर पाएंगे. So I want all the people to come along with me. That is why I'm going little slow. Yes, madam. Please go to this R.
Sir,
ओके
may I?
कार सेल्स CSV फाइल चूज
हाँ, just run that command.
आई रन इट एंड देन यहाँ पे एक पॉपअप बॉक्स आया डाउनलोड ऑप्शन में सर जो आपने भेजा था मटेरियल
So where that material is there?
सो दिस इज डेटा विजुअलाइजेशन राइट
No,
दिस
no,
इज
no, no. I recently, no. I recently shared the link. From that, you have to download that.
सर आई डाउनलोडेड इट I don't know. It's
Uh,
showing the same thing.
that is PCA and factor analysis. It has went up.
It is showing PCA.
PCA, and just come down, down.
Okay,
Yeah,
this
PCA
one.
and factor yeah.
आप open करो इसको sir. Should I open
Yes,
it?
yeah, actually open there if it is possible. But it won't be coming like this because see, there is a zip file or the it's a rare file. So
Mm-hmm.
go to download and right click and extract that, and then you will be able to see those files. In that you
Okay,
have to
first I have
select
to go to the download option and then click it, right?
yes, yes, yes. So let me share my screen. So how it needs to be done. You can just observe that.
Okay, sir. I'll stop sharing.
Yeah. So likewise, this for this zip is coming. So let me take this on my desktop. So this is the zip file you have
Your
downloaded.
screen is not visible, sir.
My screen is not visible. Let me share it again.
Yes, sir, you are visible.
Okay.
Okay, just a second, sir. I have to pin you, I guess.
Yes, maybe.
Mm,
Now I
pin to
think it might.
screen. Yeah. Pin to
Ah,
screen.
okay. So when you downloaded this file, this PCA and factor analysis is the name of the file. Now, if you
Mm-hmm.
right click on this, at that time you may find some of the options depending upon which version that you are using. So extract to PCA and factor analysis. So if I do that, then this bundle will be extracted and this kind of folder will be there. In
Acha, acha.
folder, all these files are there. Now
Okay,
from
okay, okay.
here, we have to read this carsales.csv.
Okay, sir. Okay, okay, I'll
Okay.
try that.
So yeah, I'm waiting for let's say 1 minute, and then please do it quickly so that we can move ahead.
Mm-hmm.
Okay, let me know. Shall we move ahead?
Yes, sir.
Okay, okay. So here what I had done, I had read this file and then found out the average of this car sales and standard deviation of this car sales. In that car sales, I have found out it for the price column is there, right? Now let's say I want to have a new, let's say, column. So let's say I'm creating a new column, or let's say new object, that is Z score price. Okay, there I will be storing all these values.
Excuse me, sir. Just one, sir. Car sales. What do we have to give the command? I got the
Uh,
file. Car
okay,
sales. Car sales, and then hate car sales. I did. Then we have to do. So that is done, right? Car sales read CSV
yeah,
file. Okay, sir.
you have to do this from line number 8.
Okay, okay, fine. So I have to do
Yeah,
mean price, right?
yeah. So this is I'm showing you the manual transformation. Then there is a command to do this same thing.
Mm. Car underscore sales. Car sales. Dollar price. Fine. So I have to run it, right, sir? Control and enter.
Yeah,
Mean price. Okay. Standard deviation. Price. And then I get this. Car underscore dollar sign price. Fine. Control. Run. Okay, I got it. Then we have to do the Z score.
yeah. Now Z score, that is another variable I'm creating, and here I'll be writing down the like formulas like car sales dollar, let's say, price. So what it will do, if I fetch, then only this car sales price will be fetched. Now what I want to do is I want to subtract mean from that. So mean is mean underscore this price. Okay, so for that I have to mention in this into the bracket, and then I have to subtract this mean underscore price. Okay, and then I have to divide it by SD price. Okay, this is what I did is I let me just show you in the PPT for the scaling. Yeah. This formula is there, right? So this same programming I did in R. So this is the Z score car cells, and then X, that is not the actual value, minus that is mean of the this one, and then divided by the standard deviation of that particular column. So if I run this, if I run this value, then my Z score, this thing will be appeared over here. And now if you look at this, you can see all the values are standardized now. So you can see here, this value is standardized now. Now it is not actually in the price, it is mu plus or minus 3 sigma. In that way it is done. Okay, so this is how we can do it manually. So likewise we can do it for other columns also. Now it is quite difficult to do that. So R has made our life easy. So using a scale command. Okay, so there is a command which is called scale that we can use. So if you look at the scale, what it is doing, so basically it is making a scaling. Sorry, scale is a generic function whose default method is centers and or the scale of the columns and numeric matrix. So basically it will take center and the scale as a true argument, and then it will convert this thing. So if I write down my this car cells, dollar, let's say price, and then comma, center is equal to true, and let's say scale is equal to true. And if I run this, then I'll also be getting this kind of data. Okay, so now you can see, just try to compare this. Here we are getting minus 0.40. So in manual calculation also we have got this minus 0.40. The second value is 0.074. Here also it is 0.074. Okay, so the scale function is also doing the same thing for us. Okay, now you might have a question that are we have to go by one by one column? So it is not necessary to go one by one column. Entire data frame you can do that. So let me remove this, and I'm storing in a, let's say, scale car cells, and then I'm writing down this scale into bracket this car cells. Car cells means entire data frame, and then I'm putting this center is equal to true and the scale is equal to true. Okay, so if I run this line, then it will create a new this one. And now let me print the head of it. So if you look at the head of it, then all these values are transformed in a Z score method. Okay, so why I have shown you from difficult to easiest one, so that you can see, like if you want to do some customized thing, then also it is possible. Like this manual mean and standard deviation you have calculated, and then you have calculated the Z score. Then this scale command. So many of the time, if you don't want to if you want to, let's say, convert your only a single column, then you can use this one also. And this command is also useful when you want to convert or you want to transform entire data frame, right? So that is what I shown you over here. So please come up to this level, and then we'll move ahead. If it is done, let me know in the chat box.
So can you scroll a little bit up?
Yeah, sure.
Okay, that is Z, the number 11. So it is Z score, right?
That is a Z score for the price. So that is the name I had just given. That is not the formula actually.
Okay, so
Formula is here. This one is the formula. This is what I've just
Cars underscore sales dollar price minus mean underscore
price,
price.
because I have stored mean in the mean underscore price, no?
Okay, sir. So and that is bracket close divided by SD underscore price, right?
Because as the standard deviation is stored in that
So we
object.
don't have to close the bracket out there, right?
No, here it is closed, no?
Okay. Control run. So, but when I'm doing the same command, I don't know why I'm not getting this. They're saying some error part. I did the same thing.
See, some minor mistake might be there. Just see this syntax once again.
Z underscore score underscore price. Then there's a less than hyphen sign. Bracket start car underscore sales dollar sign price minus mean underscore price bracket close divided by SD underscore price. Put it there and then control run, right? So it's not coming, so I don't know
What
why.
error it is giving?
The same thing is being typed in the console, sir. I don't know why.
Okay. Just then share your screen. I'll just looking into it.
Okay, sir.
Press Control L so that all these things will be,
Control L.
Control L.
Control L.
Yeah. Now.
This number 10. This
run that. Run that.
So it's coming on. Syntax is correct, na sir?
Your syntax seems to be correct.
I don't know. I did the same thing as you typed it out.
Okay. Run the fourth line, that is head. Head car sales. Yeah, just run that. Okay, car scales.
Oh, sorry. I think. Oh, this is wrong. It will be sales, right? SALES, sales.
Now you run that.
Okay. Now
you run that. 7, 8, and then 10. 7, 8, 10. Okay. Yeah, and definitely, yeah, you can see in the environment that Z score price is coming.
That is there.
Yeah. So what we have asked to R to perform. So we have asked R to perform this operation and save over all the output in the Z score price. So it is done like that. Now, if you want to see that, then you have to type Z score underscore price, and then you will be able to see it in a console.
So what to type key, and then I did this control R.
No, this by writing down this 10th number line, what it has done, it has stored value into Z score price and stored into the environment.
Okay.
Now have we asked? Yes, हमने ask R को ये नहीं बोला है कि ये करने के बाद ये values मुझे दिखाओ.
अच्छा ठीक है.
तो
मतलब ये सेव हो गया, ये कमांड ले लिया है R ने.
हाँ, कमांड ले
in the global environment it is showing this thing, right? और उसके बाद फिर ये 15 नंबर जो मैंने कमांड दिया, ये भी स्केल ही रहेगा सर, स्केल अंडरस्कोर कार.
ये इसमें आपने असाइनमेंट ऑपरेटर नहीं दिया है ना. See, that is the name, scale car sales, that is the name I had given.
Okay.
Name you can give anything, you can give ABC, anything.
Okay.
But after that you have used underscore, right? So actually it is assignment operator, like less than and hyphen sign.
Okay. So
after
वो
less than equal,
कार सेल्स के बाद वो लेस देन इक्वल टू होगा, राइट?
लेस देन इक्वल टू,
less than this one, right?
This
is
now
the
if
operation.
you run that, now you run this.
Error in scale, car underscore sales dollar.
I think center is not there. Center you have written wrongly. Actually it is CE and TER.
Okay. Okay.
Yeah.
Now I can run it.
Double equal to is there. Yeah, now it is done, and you can see that is also there in the
Okay,
this
cars. Yeah, yeah, yeah.
environment.
In
Yes,
the
yes.
environment.
So likewise, if you remove this price, you
Hmm.
remove this price from the 15 number line.
50 number
15
line.
number line. Yeah. Not that
Price.
one. Yeah. Car sales dollar price जो है ना वो price remove कर दीजिए.
हाँ.
Okay. Still dollar is also removed. Remove करिए.
Hmm.
अभी रन करिए इसको. Control enter करिए सर. Control enter मैडम.
Sorry. Control enter.
Yes.
इसको
Now you
फिर
can see.
हाँ.
Now you can see scale car cells. In that all the variables is standardized. Now if you print this head into bracket this scale car scale cells, it is 21
इसको
number line.
हाँ हाँ.
Run that.
Okay. अच्छा
Now
अच्छा.
it is standardized for all the variables.
Okay, okay, okay.
Yeah. Okay.
Thank you so much, sir.
Yeah. Thank you.
I think I
Okay.
should
Now
stop
we'll
here.
move ahead. So that is how we can standardize the value. And there is another method
Sir,
like
one
mean.
question.
Yeah, please.
Sir, whenever we do standardize, so before that, if you just share your screen, there are 152 observations which are standardized. Okay, whenever we doing the first command, okay,
Right.
manually. Then again, when we are doing automatically for all the variables, I think in my result, the observation falls to 111. The
111.
standardized observation, yeah, because in the output when I recall the when I call the cell scale car cell variable, then it is only given 111 variables. I don't know why, only standardized values, but it is here in the
See,
environment it is
in environment
in
you
the
might be seeing 154.
yeah,
Sorry, 152.
they are 152. There is
Yeah.
152, but the result is given 111.
Actually, it is not 111. Let me just tell you how it can be visualized. So see 111. Okay.
Huh.
After that. Okay. So see what the option it is giving. It is telling you that it is actually more than that, but there is a limit of this maximum printing. Otherwise, if you are having let's say 50,000 data, then this console will be full of that.
Okay, sir.
So
Okay,
whatever
okay.
analysis that you will perform, that will be on 152 only, but it is having some predefined limit. So it will after that it will not print you, but it will give you the
So it
ID.
has also shown
Okay,
that
okay.
41 rows are omitted. Over there,
Omitted. Yeah, it is
yes,
omitted.
omitted 2041 rows.
Yes.
So that
Omitted
means
means.
yeah, that means some rows are not shown.
Yes, exactly. Not shown. It is not omitted from the data. Now, if you click on this
So
here in
from
the
that, can we conclude that whatever be the data, we will see only 111 rows?
No. It is different for all these options. Actually, there is no fixed
All
limit
right.
over there. Many of the
All
time
right.
after 50 also it is saying. Many of the time 99 it is showing. It depends upon
Okay.
the backend setting. But
Okay.
there is an option. You can explore this. See, get option is there, right?
Right.
So in that you can share some of the set some of the limits like maximum print, right? Maximum
Okay.
print is equal to let's say 1,000 or something like that.
Okay.
There is a command actually, so that you have to give so that it will print up to 1,000 rows. So likewise you have to do something.
All right. All right.
Yeah.
Okay, sir. Thank you.
Okay. Now I'm skipping this part. The syntax is given to you for your study, that min max transformation or min max normalization. So that is the same I did it for manually over here. So I'm just skipping that because we are not going to use it. Now actually we are going to do the principal component, the most awaited part. So PCA. Now to perform PCA, what we'll do, we'll save first of all this model to some object. So I'm calling this object as a PCA car cells. Okay, please remember this is the name, huh? So I can give, let's say Hiren PCA also I can give, or let's say only PCA also I can give, but this is only the name. So you can give as per your preference, and then you can write down PRCOC. Now it is showing you the pop-up that PRComp is the function. What this will do? This will perform a principal component analysis on a given data matrix and return the result as an object of class PRComp. So it basically it will perform PCA and save all this result in let's say object or that model format. So PRComp. Now here what we have to do? We have to give a data that is X is equal to tar cells. Okay, and then there is a option called center is equal to true, scale is equal to true. So please whenever you are a beginner, right, so at that time try to use this autocomplete functionality. So how it can be used? So please observe here. So I can press tab. So as soon as I press tab, at that time it is asking that these are the argument it is taking. Okay, so from this I would like to have this center argument. So as soon as I click on that, center and equal to sign will be automatically coming. And here I can mention T. T means true. I can mention either T or I can type this true like this also. That is also perfectly fine. And now to make it more visible, I'm just taking this to the next line. Here again, I'll put a comma and then I'll press tab. So I can see this scale dot is there. Please remember scale dot is there. Just double click on that. It will come, and here also I'll be adding this T or true. So what it will do? Here I've given the data of original value. And if I add this two argument over here, then automatically it will convert that. So I even don't need to use this one. Okay, because here in the function itself, there is a provision to do that. Now, if I run this, you may see here, nothing is coming, and just that, syntax is coming. But if you look at the environment option, there is this PCA car is there, right? So there is a second option, PCA car, which is storing some of the values over there. Okay, but like how to see it? So here it is coming, but how can we see that? So up to this point, everyone has done this one.
Sir, when I am doing PCA with using the Z score, then only the center and scale option has to given.
No.
When I am doing this with normalized value, then also have to given.
No, then it is not required. Actually, I am using here the raw values, that is actual values that is given in that this file. Okay, so here it is a raw value, that is not standardized value.
Okay.
And that is why I'm giving here itself that you do at center and scale. So as we perform over here, right? So you don't need to do it separately, but there is a facility to do that. That is why I explained this function. But here you add this two argument, it will do the same thing on this original data, and then it will perform its procedure.
Okay.
So please do this, and then we'll move ahead. Once it is done, please let me know in the chat box.
Sir, here's the syntax. In case of center, you have written true.
Right.
Whereas in case of scale dot, over here only T has been written. Whether there is any difference?
There is no difference. There is no difference. So T also means true. So basically it is a logical value. So instead of true and false, you can write T and F in capital.
Okay. So there is no difference. And sir,
there is no difference.
So another thing, I just want to know that what is this scale dot means?
Actually, that is the syntax which is prepared by this one. Actually, that dot is the part of this function. So now the person who had designed this function at that time, he might have kept this argument.
All right.
Yeah.
Okay. Nothing else. Okay. Thank you, sir. Thank you.
Thank you. Okay, done, everyone.
Done, sir.
Okay, okay. So I think very few people are following with me. Is it so? Okay, anyway. Now let's say we are interested to know that after performing this PR comp command, what kind of information it has stored. So how can we see that? So one thing, first of all, we can use this attribute command. So attributes. Okay, if you write down these attributes and into bracket you will give this PCA car sales. Okay, so here this is there, right? So we can select this one, and if you run that in the console, you may see this one, that it has stored SDEV, it has stored the rotations, it has stored the center, it has stored the scale, and it has stored the X. And the class of this data, okay, that is PR comp. Class means its type actually. So like we have data frame, matrix, array, list, vector. So likewise, the class of this is a PR comp. That is the class of the model. But we don't have to do
Sir,
anything with this. We are interested for this 5.1. Yes, sir.
sir, PRCOM is related to single variable decomposition, right?
Yeah, it is SVD. Yes, single variable
Okay.
decomposition. And
Okay.
if you look at the another option is print comp. Okay, so this print comp is for that spectral decomposition.
Okay, sir. Okay.
Now, if you look at this one, so if you have run this attribute, you can see this 5 values are stored in this PCA car cells. And if I show you my PPT, yeah, so here also you can see the same thing. SDV, rotation, center, scale, and X. So these are the 5 values it is storing. And what is the meaning of that? So all this mentioned over here. Okay. Now, if you want to access one by one values, then how can we do that? Okay, so whenever you want to fetch some values from the model or from the data frame, we use $sign. So we can use this PCA underscore car cells. Now dollar, you can see all these 5 things which is storing over there. So SDEV. If I run this, I'll get this kind of value. Okay. Now let me just okay. Now as soon as you run this, it is showing you the SDEV. Now what do you mean by that? It is the standard deviation of the component, principal component. Okay. Now if you want to see the rotation or the loading, okay, then it is how we can do that. So we can access this PCA underscore car cells dollar rotation. And here you can see how many components have been made. So PC1, PC2, PC3, 4, 5, 6, 7, 8, and 9. Okay, total 9 components have been created. Now here you can see how many variables we do have. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it is basically a 9. How it is correlation between this PC1 and this price is there, PC2 and this price is there. So likewise it is shown over there.
Sir,
Yeah.
Sir, in my analysis here, 7 principal components are showing.
7. If you just go down, then it might be there.
Oh, okay. Sorry, sir.
Yeah. So it depends on like how your because I have make it zoom. So here it is accommodating only 3, and then another 3 will go down. Likewise, it will be there. Okay, another thing, let's say this is basically a variable loading, or you can say the eigenvector. Now here we would like to have the center of the this variables. So we can access this PCA car cells dollar, let's say this center. Okay, and here you can see this price, average price is this, engine size is this. Now if you want to double check this, then there is one function which is called COLMEANS, col means. Okay, col means, and in that you can give this car cells. So here in front of you, both the things are there, and you can see it is all equal. So basically, it is a mean of the price, mean of the engine size, mean of the horsepower, mean of the wheelbase. Likewise, it is storing. Now, if you want to fetch another component, which is known as a, let's say, a scale. Scale is what? Scale is nothing but the standard deviation of the variable. So here, if I calculate the standard deviation of the price, let's say, then it's SD into bracket car sales dollar price. You can see it is coming equivalent to this, the values. If I do this for car sales dollar, let's say, engine size, then also it is coming to same, right? So that is the information that we are getting. One is like mean and the standard deviation, and another one is x. What is x? Let us have a look at it. X is the coordinate of the individual observation on the principal component. Now here in the rotation, what we have observed, in the rotation we have observed that each variable with each component, but when you run this x, at that time each value, so each observation, yeah, so here you can see this first observation is having loading of this minus 2.95 in PC1 and minus 0. Let's say 31 in this one and this one. So you can see here where its maximum loading is there on the PC1. Okay, out of this other one. So likewise, it is arranged actually. If you go like this, it is getting, let's say, reduce and reduce and reduce likewise. So this is how we can access all these points. Now see, in this is all individual points we have access, but we want to make a summary of it. Then we can use a command called summary. So summary of PCA and then car cells, and you can see here how much variation that has been. Yeah. Yes, you can see here how much variation the first component is explaining. So here it is shown in the form of standard deviation. So that is 2.4092, and this component 2 is explaining 1.23, and as you go along, it is in a descending order. So this is how, like, principal component 1, how much variation it is explaining about your original data. So that is coming here. Now what do we mean by the proportion of variance? So that is, let's say, 0.64. Okay, now 0.64 is nothing but the 64%. It is proportion, so that is why it is in a decimal, like 0.64. But if you multiply this with the 100, then you can say it is a 64% of the variation of original data set that can be alone explained by this PC1, this principal component 1. And if you look at the principal component 2, then it is explaining about 16%, 16.86% of the variance, out of all this original data set. Now, if you make a total of both this variable, like 64 plus this 16.86, then it becomes 81.35. So if you consider only two principal component, and then you use this in the model, then it will retain 81.35% of the original information. You'll have a lose of, let's say, you have a loss of 19% of the information. But let's say your target is to be beyond 90, for example, then you have to come to this level, and you have to consider 1, 2, 3, and 4 component you have to take. So it will give you, or it will retain you, the 92% of the information compared to the original, and it will reduce your dimensionality by 50%. How 50%? Original we have 9 variables, but instead of that 9 variable, if you study only 4 variable, then you'll have 92% of the information. Okay, so that is how this is done actually. Now the question is, can we visualize all these things? Okay, if you want to make a visualization of it, then can we do that? So yes, we can do that. And for that, there is a concept of scree plot. Okay, so I can type this command called scree plot, and there I can just give a model. I don't need to give anything, because R is smart enough to fetch which information to be graph. So scree plot into bracket this PCA car cells, and if I run this, now here margins are too large, it is showing. Yeah. So it is in a descending order, that how much variation it is explaining. Okay. Now if you want to change, generally scree plot is not in the bar form, actually it is in the line form. Yes. So if you mention this scree plot into bracket this PCA car cells, and type is equal to L, that we understood yesterday, if you remember. So L means line. Okay, if you run this, and then you will have this kind of graph. Okay, now what it is showing basically, let me go to PPT, because the same graph I have taken over there. Yeah. So here you can see there are three components, which is explaining much more information about this one. Okay, and you can also change the color and everything, like main and all. So let me give that also here in this case. So I can change the color of it. So color is equal to, let's say, blue, and then main is equal to scree plot, and now you can see here. So here you can see this first component is explaining maximum variance, and the second component is like this much of variance it is explaining, and the third component it is this much of variance it is containing. Now ideally, how many component you should take into account? Okay, so in that case you have to see this diagram as a elbow diagram. Let me copy this image, take to the PPT, and show you. Okay, so it is like an elbow. So where this turning point is coming, so you should take, it is coming like this. Okay, so this is elbow. Now when this is the elbow point, before that all these component you should take into account, and this you may leave. Okay, but again it is a question of like how much variation you can allow in your data or in your model. So let's say this three component together, they are explaining how much variation. It is 88%. Okay, so if 88% is okay for you, 88% is okay for you, then you may leave all this other information, and you can take this three component and go ahead in your multivariate analysis, or let's say further analysis. So this is how we can use the PCA to decide like which component to be taken and which component to not be taken. So yes, is there any query? I hope
Sir,
yeah.
sir, when we got the result of PCA card cells, there are the values related to the each variable with the principal components. Now, is the values are basically the weights?
Yeah, these are the weight actually. So when you go for this reverse calculation, let me just have those values. I think you're talking about these values, right?
Yes, sir. Yes.
Yeah. So these are basically the weight of that one, right? So now when you are using this PCA1, PCA2, and PCA3 for your further analysis, and you again come back to, let's say, original one. So at that time you have to multiply this value with that data and do the reverse transformation. It is a bit difficult process, but yes, these are basically the weight W1, W2 that we were talking about, right? So that is this one.
Okay, sir. Okay, thank you.
Yeah. So I hope it is making a sense. Like, don't worry if you are, let's say, not able to remember the syntax, because say this, R programming or any software or any programming or any software analysis, you need some practice to have a command on it. So you might be thinking that I am doing in a fast way. So I'm using since few years. That is why, and daily I have to use it. So that is why I have got a little command on it. But R is also like an ocean, और उसमें से मुझे कितना आता है, मुझे थोड़ा बहुत आता है. Okay, बहुत कुछ सीखना बाकी है. But basically the फंडा हाँ क्लियर हो रहा है कि नहीं हो रहा है, that I wanted to know.
सर एक बहुत ही बेसिक क्वेश्चन, आई डोंट नो, इट्स नॉट रिलेटेड टू कैलकुलेशन पार्ट. जब आपका ये आर्ट स्टूडियो में द कलर ऑफ द टेक्स्ट चेंजेस टू ग्रीन ना, then do I have to understand that something is wrong with that syntax or something like that? Because normally because the moment.
Here, okay, see, basically whenever you are giving any text over there, right? So anything is comment. This is in my setting, right? Your setting might be different. So here it is in my command, it is showing the green color. Whenever I give any logical value, it will turn into the orange color. That is the setting I have used. That is why it is showing like that. And that is by default setting also. Like if you use that comment and all, at that time by default it will give you in a green color or so, I suppose. But that all you can change from the option. Like if you go to this tools, global options, and here you can click on this third option, which is appearance, and from here you can select the theme and all. So here it is giving you, like if I go like this, then I'll be having this darks, this one also. So if I select this one, all these things will come in a dark way.
No, sir. Yesterday also I observed that in one of the other participant also, no, that participant started having problem when the command, when you are doing the syntax automatically without you actually changing the color, it turns into green. So somewhere again we had to rewrite. We have to erase all the part and then do it again. So
That might be some error, I suppose.
So
Yeah.
does this indicate that when the color changes automatically until unless you have typed some command, that means you have to understand that there is some problem in your script and then you have to again rewrite it. Is that so?
Okay.
Or
Yes, basically, this command will have the same color. So for example, this summary is a command, right? This PCA car sales is an object. So they all have the same color, like white,
yeah.
white, white, white.
ये
And now
वही
let's
same
say
color आ रहा था,
if
but
I'm,
अचानक
now if I'm writing down this summary and let's say it is coming in a green color, then it may have some problem. Like either there is a syntax error, or there may be some other error. So in that case, you have to look at it.
Okay, because the script plot तक आ रहा था मेरा PCA car cells, and then when we changed the color to blue, it didn't came. So type 1 में उधर कुछ it started coming
So
in
it
green
may
color.
be here some, yeah, it may be some, problem might be
Yeah,
there here and
the one
somewhere.
which you're showing the.
Yeah.
Okay, sir.
Yes. Yes, I'm not getting response from all the people. I'm getting only response from 2, 3 people. So if you are having query, then raise your query.
Sir, may I?
Yeah, please, ma'am.
I'm a student of zoology, and now I am doing my postdoc in biotechnology. But I am a layman of this all these things. But today I am tried all these things. You are already presented on us, and then I am found that yes, I can do it.
Thank you, madam. Actually, that you rightly mentioned that you're layman for this, and I try to explain in a layman language because I am also a layman.
No. Thank you, sir. Thank you, sir. Thank you for your nice presentation.
Yes.
So may I ask one more layman question, sir?
Yeah, madam.
You permit? Hello. Hello.
Yes, sorry, actually, here electricity went away, so my Wi-Fi was disconnected. So I was.
Oh, I thought that someone, I think a problem was from my end.
Yeah.
सर मुझे दो लेमन क्वेश्चन फिर पूछना है.
Yes, please, ma'am.
सर कमांड हम जब देते हैं तो फर्स्ट पेज में जो आर स्क्रिप्ट में दे रहे हैं तो कभी
हाँ.
कभी सर आप मुझे दिख रहा था कि आप कंसोल में भी कुछ कमांड दे रहे थे.
Okay,
सो
okay.
हाउ डू वी डिसाइड, वो वाला एक पोर्शन है कि कब कमांड कंसोल में देना है, कब कमांड आर स्क्रिप्ट पोर्शन में देना है, वन. और सेकंड, अच्छा ठीक है सर, पहले पूछ लेते
Yes,
आप
yes,
आंसर.
yes. Yes, I think this confusion, if anyone is new to R, they might have the question. Okay. Now, see, when you type any command in the R script, it will be there, and you have to run this. Okay, so you have to do like this. But when you write command in console, you just press enter and it will run automatically. Let's say here, if I type this car sales and then dollar, let's say price, it will. If I press enter, then it will all will come, right? So console में आपका output आता है, and here in R script you are writing all the code. Definitely here also you are writing the code, but it is generating immediately output. You can save your script file. You can't save this console one.
Okay. So the
So when
the objective behind putting the commands in the R script is to वो save करके रख सकते हैं
save,
कि बाद
yes,
में देख
yes,
सकते.
yes. So for
अच्छा.
example, here this file I want to save and I want to give it to you people because this is the live example we had done. So if I had written all this command in this
Console.
console, then output will be there, but I will not
But
be able to share that
command.
file with you.
Okay.
Okay, so that
Sir,
is the basic difference.
okay, sir.
Yes,
तो
sir. I am also following your R script format of this your presentation, and I
Yes,
am
yes.
just copying this our comments, and then I will able to get the result.
Okay, okay.
सर दूसरा लेमन क्वेश्चन ये था कि सर कल आपने जो करवाया था टास्क आर स्क्रिप्ट
हाँ,
में,
हाँ.
तो उसको सेव हम लोग किस कैसे करेंगे सर? लाइक आई वांट
Okay.
टू सी इट अगेन, सो
Yes,
हाउ डू
sure,
आई
sure,
सेव इट एंड
sure.
स्टार्ट? अगर
So
फिर दूसरा आज जो आपने पीसीए सिखाया,
yes,
सो हाउ
sure.
डू आई स्टार्ट इन द सेम थिंग लाइक?
Okay, so here I have written all this command in my this untitled, that is a fresh script file, right? Now I want to save this, so I'll simply press Control S, or there is an option like save symbol over there. So click on that. It will ask you that where to save. So let me save it on a desktop. That this is PCA and let's say PCA analysis. Okay. And then for a like it will take automatically that extension, but this is my practice. I'll use this .r because I'm working in, let's say, C++ and this Python and all. So extension, to write extension, that is preferable, otherwise it will automatically identify. So I'm writing analysis.r and save it on a desktop. Save it. Now you can see here name is changed analysis.r. Now if I close this file and I want to reopen this again, I can go to the my desktop and here this file is there. Let me open that. This all the codes will be there.
Okay. And
Okay.
then if I did this thing, save किया और उसको फिर हटा दिया, and I can do this thing, right? एक ऑप्शन था इधर
Yes.
साइड, ग्लोबल एक्सपेरिमेंट में, ग्लोबल एनवायरनमेंट में एक ऑप्शन है सर, वो ब्रश जैसा है ना, क्लियर ऑब्जेक्ट फ्रॉम द वर्कपीस, तो उसको
Yeah.
क्लियर कर सकते हैं, एंड देन
Yeah.
वी कैन न्यू स्क्रिप्ट स्टार्ट करके दूसरा काम कर सकते हैं, राइट?
कर सकते हैं. Yes.
Okay, sir. I know these are very stupid questions, but
No,
I'm
actually, it is not
asking.
stupid question, but see, we have to deliver depending upon the content. Otherwise, these are the basic things which is very much essential. Now, if you don't know how to file, then if I tell you about PCA factor or anything else, then if you're not able to skip or save those files, then it is less meaningless.
Yes, sir.
Yeah.
नहीं, कल एक्चुअली आपके सेशन के बाद आई फॉरगॉट टू आस्क यू हाउ टू सेव दिस, तो दूसरे सर का जब स्टार्ट हुआ तो आई वाज नॉट नोइंग लाइक कैसे करूँ सेव एंड ऑल दैट थिंग, सो आई थॉट आई
Okay,
आस्क
okay.
यू.
Not
Thank
an
you so
issue,
much.
not an issue. Yeah, thank you.
Done.
Yeah. Now we are going ahead with our factor analysis. Now see, as I explained that there is a some of the purpose like dimensionality reduction is also one of the purpose of the factor analysis. But here main thing is that we want to give a name of those group. Let's say in for example in PCA1 all the loadings are there, but in this factor analysis only some of the variables will be having the highest loading, and that we want to basically find out, and we want to make a group of it. So we'll, as we go along, we'll be able to reconnect. Now, in a social research field or any like life science research, the researchers usually investigate many variables. Okay, so if you are, let's say, in biology, then also you are too many types of genes and all that you are studying out, right? And to study the structural relationship which leads to draw a conclusion about the population. So that is the purpose that we already discussed now, right? In ANOVA, regression, discriminant analysis, one variable is clearly defined as a dependent variable. So if in regression also y is equal to function of x, or y is equal to, let's say, beta 0 plus beta 1 x1, that kind of thing we are doing. So there, this y is clearly defined. But here, in, let's say, the example previously we have seen of the car cells, there is no variable which is, let's say, dependent variable. Here in the factor analysis also, there is no variable which is dependent variable. Okay, so let's say if we don't have any dependent variable, then what type of analysis we can perform? Or is it like that, that we can't perform any analysis if there is no dependent variable? So the answer is no. You have some technique that you can perform. Now let's say we are having too many variables that we are entering into our this analysis funnel, and then we are doing some relevant processing, and then ultimately we are getting all this meaningful information out of that. And that is what the purpose of this analysis. It may be PCA, it may be factor analysis, and basically we want to classify them as a factor. And this factor analysis is also primarily used for the dimension reduction technique. Now, we need to understand that what is dimension here. So let's say if we are having this data where this serial number V1, V2, V3, V4, V5, V6 are there, and here it may be person 1, person 2, person 3, likewise it is there, 12 person. Now, rows and columns are nothing but the dimension. So if you know in R also, for any data frame, if you use dim command, and if you say give this car cells, that is just we have used, then it will give you rows and columns. So let me just quickly show you. You don't need to follow that. I'm just showing you. So no need to follow that. And some of the thing I would like to do temporary, because I don't want to save it in a script file, so I'm doing it in a console. So let's say dim into bracket, let's say car cells. So what it is showing me, 152 and 9. So 152 rows and 9 columns. So that is the dimension. Now, if we want to, let's say, reduce the dimensionality, let's say for the rows, then what we can do? So we can select, some of the rows randomly, or maybe some systematic way we can do that. And that technique is called sampling. Okay, so when we want to reduce our dimensionality with reference to the rows, that is number of observation, let's say 500 people I have interviewed, out of that I would like to select only 100, then likewise I'll be selecting some of the rows randomly, or some by giving some logic like stratification or something like that. So that is known as a sampling. Okay, now when we want to, let's say, go for the column, then what we can do? So can we do like this? So as we did in this, this one, again, look at this. Some of the, rows we have selected randomly. So likewise, can we go for the column selection also?
No, sir.
No. Yes. We cannot go like this, right? So that is the right approach. Nahi hai. That is the wrong approach actually. So for that, we have to use some systematic way to do that. Okay, and that is why we are using this factor analysis or principal component analysis. So basically, a factor analysis approach is the data reduction in fundamentally a different way. Now, this is the model, like you can say, it is a measurement of a latent variable. So basically, it tries to identify a new variable. Now, that is, new variables are nothing but your factors, which will store the information which is not explained by those other variables. And the latent variable cannot be directly measured with a single variable. Okay, so think, let's say if I want to measure an intelligence level, then by asking a single question, can I measure this intelligence level? No, we can't do that, right? So I'll have to ask some of the question, like statement 1, statement 2, statement 3. Likewise, if I am asking, let's say 15 statement, and the person is giving some answer, and out of that, I can study the intelligence. Okay, but now whenever we are using it our model, at that time it is difficult to accommodate all these 15 variables. Okay, similarly social anxiety, that is also cannot be, we cannot ask a single question and then we can come up to that level that the social anxiety of that person is so and so. Instead of that, it is seen through that relationship is caused a set of the y variable. Let me just remove this. Yeah, so for example, we can, we will not be able to directly measure the social anxiety, but we can measure whether social anxiety is high or low with a set of variables. Like if you can ask that, I am uncomfortable in a large group, yes or no, or scaling kind of answer we are getting, or I get nervous talking to the strangers. So in that 5-point scale we are using. So likewise, if there are so many statements, based on that we can, say whether that person is having the social anxiety or not. Now, people with the high social anxiety will give a similar or the high response to the this variable. So, if let's say, this is 1, 2, 3, 4, and 5. This kind of ratings are there, where this is, let's say, strongly agree. This is agree. This is neutral, disagree, and strongly disagree. So, let's say if they are having the high anxiety, then their answer would be near to this. And let's say if they are not having this anxiety, then they will have an answer to this. So likewise, basically this factor analysis tries to identify this pattern that, if let's say they are, having the social anxiety, then in which direction their ratings are going. And if they are having low, then in which direction it is going. So likewise, it will identify the pattern and then will return you that, these are the groups which is there in the data. Now, as we seen in the PCA, you can see here in this diagram that this is the factor, and then this is the y, and these are all the, let's say you can say coefficient or the weight. In fact, okay. So I don't want to confuse with more terminology, but ultimately it is a weight or the loading that is about this y1, and there is some uniqueness that this variable is explaining. So that is called uniqueness. So unique information. So this variable is giving some unique information, this variable is giving some unique information, this variable is giving some unique information. So every variable is giving some of the unique information. So that also we are studying in the factor analysis, that as an individual variable, what unique information it is sharing. So that is also we are calculating from this, and it can have this kind of model actually.
Can you
So it
give
is
one example about this thing? Unique, आपने बताया U1 unique information or given by Y1, right? Which has a
yes,
weight, a factor loading of F1, and all
okay,
this together combined gives a factor F. Are you?
yeah,
Can you give some
yeah.
examples, sir?
Lemon example chalega?
हाँ सर एकदम
Yes,
सब
yes,
लेना है
yes,
यहाँ पे.
yes. Because I also, if some story kind of thing is going, then it is easy to understand. So let's say you want to collect an information about me, Hiren Kakkad, right? So if you are, collect information about me, then you can interview some of the person who are closest to me. Okay, so you have catch one person who is my friend, okay, my best friend you can say, and you ask about few question about me, and he has given you the answer, but it is not 100%, right? So he has given, let's say, 70% of the answer, or the 70% information about Hiren Kakkar. But your aim is to maximize this one. So what you will do? This is closest one, and now if you go to the, let's say, closest two, and then closest three. So you may go to this different people, and they are giving you some information. Now here it is sharing, let's say, 80%. Here it may be sharing, let's say, 65%. Out of all this information, some of the information will be common, right? So like my education and my let's say background and something like that will be common in all these cases. So let's say that common thing is called, even in this factor analysis it is known as a communality. Or let's say the 50% of the information is common across all. So how much uniqueness here is there? So here 20% information is unique, here 30% information is unique, and here let's say 15% of the information is unique. So that is what uniqueness that we are aiming to. Okay, now let's say you have interviewed 50% and ask about my information. Now, what is our ultimate aim? So we would like to, see like how this information is distributing actually. So by performing the factor analysis, you may see like out of this 50, 20 people, they are sharing the, similar type of information. This, let's say another 15 people, they are sharing some, similar type of information, which is not actually related with this, but there is some other information that they might be sharing, and some more 15 people, they are sharing some third type of information. Now, if you, go into the detail of it, then you may find that these 20 people are my, let's say, college friend. Since they are sharing the same information, they will have more information about my college life. These 15 people, they might be telling you about my social life because they are my relative. Okay, so the second one is, let's say, relative people. Okay, and the information you are getting is a social life. And this might be, this 15 other people, they might be sharing about my professional life. So they might be my colleagues or my clients or something like that. But when you started this study, at that time you were not having the idea whether it is, falling in the group of relative or the this one or this one, and you are also not having the idea that whether they are, sharing the information about social life, professional life, and the college life. This is how actual this factor analysis will be done. So this is, I try to explain in a layman language, and there is no mathematics associated with it, this example. So I hope it is making a little bit of sense.
Yes, sir.
Okay. Now let me go ahead. So here it will, create this kind of model. So as I explained that we are not going to, because see, you have seen that in PCA, we have not used any of this kind of formulas over there because that is, running in the backend, but it is given for your reference only. Now, this in many studies, there may be, large number of variables, and most of them are correlated. So as I explained that, some of the information will be correlated. Okay. So if it is correlated, then you can, reduce. Like for example, everybody is talking about my college life. Then you don't need to, interview 20 people. You can ask 5 people, and then you can move ahead. Okay. So if they are correlated, then you can reduce it to a manageable level. And relationship among the set of many interrelated variables are examined and presented in the terms of few underlying factors. That is, let's say here in this case, college life, or let's say social life, right, and the professional life. So likewise, you can, create a 3-factor out of that. And some other example, like store image may be measured by asking respondent to evaluate the stores on a series of item or the question or the statement, right? So how do you feel about this store? The service of this store is good or not? So there you are asking some of the questions, and then you may ask that some of the people are giving importance to only the, let's say, service level. Some of the people are giving importance to only price of the store. Some of the people are, let's say, giving importance to the packing of the item. Okay, so likewise you can, segregate that, and then you will have the idea that you are having, let's say, 3 segment of your, let's say, target customer, and accordingly you can make some of the strategies. So in the practical example also, we'll see about the toothpaste. Now, this is what it will give you the factors about the store image. Now if you take an example, then here this table is showing the correlation metrics of this, viewing TV programs in UK. Okay, so here these are the programs. Okay, so professional boxing this week, today, and these are the programs actually, and these are also the program. Now, the correlation between them is shown over here, and here diagonal value will always 1 because x1 and x1. Okay, so the correlation between them will be always 1. Okay, so likewise you have got the correlation matrix. And here what information we can get is, let me just clean this up. So the table shows that people who watch World of Sport frequently are more likely to watch professional boxing frequently. So here you can see this World of Sport. So the people who are seeing World of Sport, they are also having high chances that professional boxing also they will be seeing, because it is 0.5 and here it is 0.1. So, compared to this today, the professional boxing is having the highest correlation with this one. So likewise, we can, identify the patterns and all. So here you can see it is sorted now. Sorted means lower highest to the lowest. So 0 0.6, 0 0.6, 0 0.5, 0.3, 0.2, 0.1, 0.1. Likewise, it is sorted. So you can see here how much it is correlated or with the other programs. So this word of sport world of sport, that is correlated with this grandstand, then match of the day and professional boxing. So here the relationship is very high, you can say. Up to this level also you can go, because it is having the high relationship. So it is making one group of the people who like this kind of problem, this kind of programs. Similarly, you can study other one, and then you can find out the group of people, and based on this program and their taste, you can divide those group, and accordingly you can decide your strategy to tackle that market. Now here this is the example which is in line with this one, so I'm just skipping this one because it is explanation of that only. And here it is making the how it is making the factor. So basically you have sorted and you have perform all this analysis, and then you'll come to know that professional boxing is contributing to this factor 1, that is 0.7, and here it is 0.1, here it is 0.1, and here it is 0.7. Likewise, it is loading is coming, and you can see here the variable that measures whether or not someone watches professional boxing is relative to strongly correlated to the first factor, that is 0.73. So this one, okay, and has the slight correlation with this one, that is this one. So this particular this week program will go into this factor 2, this will go in this factor 1, then this will go in a factor 1, factor 1, factor 1, then factor 1, because you can compare this both the values. So highest the loading, it will go in that factor, and in factor 2 this will be there. Now based on this program details, you can identify that this factor 1 usko kya naam dena hai, what name we can give, whether it is, let's say, a sport programs, and here it may be a news program, okay, this week and today and all. So that might be a news program, or let's say some serials or something like that, and here it may be something else. So likewise we can identify the group.
Sir, one
Yes.
clarification.
Yeah.
So that means if I just classify the or differentiate the PCA with factor analysis, so PCA basically creating some principal component as a weighted of the independent variables, or
Right.
the variables given, right?
Yes.
And in the factor, they are mainly some combination of people or individual, or the individual on whom the data set is collected. They are creating a group, right?
That's true, very true. Yes.
Okay, sir. Okay.
Now, what is the purpose of this factor analysis? So basically to identify the underlying dimensions or the factors that explain the correlations among the set of variable, and to identify a new smaller set of uncorrelated variable. Because say in the same example, if I'm repeating that, one is my college life or college friends, another one is social one, and another one is my professional one. Okay. Now, here there are, let's say, 5 people, or let's say 10 people. So person 1, person 2, and person 10. Here also you have interviewed person 10, and here also 10 person you have interviewed. Now the correlation between these people, वो कैसा होगा? P1, P2, P3, P4 up to P10. The correlation between the information that they are providing, ये कैसा होगा?
High. It will be
Obviously high.
Yeah.
Similarly, for these people also it will be high.
Yeah.
For these people also it will be high. But if you check the correlation between this college group,
friend, social friend.
it will not be correlated. That is what the second page
Uncorrelated.
is telling. Yeah, it is uncorrelated. Because that is what our purpose is. No, if it is correlated, then it will not make a different group. It will be merged
The
together.
same one. Yeah, it will be matched together.
Yes.
सर बट कभी कभी एक्सेप्शनल हो जाता है ना, आपकी कॉलेज फ्रेंड सोशल फ्रेंड भी रहता है, आपकी प्रोफेशनल
हो
फ्रेंड भी
सकता है.
रहता
Yes, हो सकता है. And that I'll explain you at the time of like rotation, because there is a treatment that we can give you.
ओके
Yeah.
और सर तब एक सर ने आपको रिसेंटली एक क्वेश्चन पूछा था वो फैक्टर और एनालिसिस और पीसी के बारे में, तो जब वो 0.7 और 0.1 आप दो दिखा रहे थे ना फैक्टर,
हाँ.
तो एक्चुअली उसका मतलब इंटरप्रिटेशन क्या है? जब मैं बोल रही हूँ फैक्टर 1 प्रोफेशनल बॉक्सिंग 0.7 है और फैक्टर 2.1 है, ये क्या वेरिएबिलिटी एक्सप्लेन कर रहा है? 70% ऑफ ये मतलब मुझे समझ में
Actually,
नहीं आ
here
रहा है।
in this particular one, it is showing the correlation. So this factor 1 के साथ प्रोफेशनल बॉक्सिंग वाले का जो like this is my variable.
कोरिलेशन
Okay.
है, हाँ हाँ
Variable 2,
हाँ
variable 3. Likewise, it
हाँ
is variable.
हाँ,
So professional boxing is having high correlation with this factor 1 compared to this
अच्छा
factor 2. So it is showing the correlation.
अच्छा, ये फैक्टर 1 क्या हो सकता है? लाइक जब आप वो चार्ट
Yes, that is the this role of researcher, and he has to identify, he or she has to identify that okay, this my group is, let's say, 0.7, 0.8. So these are the programs, or these are the values which is going into the factor 1. So 1,
अच्छा
2, 3, 4, and 5. Okay, now by looking at this pattern, what you can give name to this group, and that is another key difference. In principal component, you don't need to give the name to the components, like component 1, 2, 3. You don't need to give the name over there, but here in the factor analysis you should give name to that, so that it can be easily identified. So as we had given in my example, that okay, if they are much more talking about my college life, then they might be my college friends. If they are talking about my social life, then they might be my social, relatives or my neighbors or something like that. And if they are talking about my profession, then they might be. So likewise, as a researcher, you have to give these names.
तो सर फॉर एग्जांपल ऐसे मैं बोल रही हूँ, जैसे प्रोफेशनल बॉक्सिंग, वर्ल्ड ऑफ स्पोर्ट, ग्रैंड स्टैंड, मैच ऑफ द डे, रग्बी स्पेशल, इसका हाई कोरिलेशन है विद फैक्टर 1. तो
Yes.
इससे ये फैक्टर 1 ऐसे बोल सकते हैं दीज आर ऑल स्पोर्ट पर्सन और
Yes, exactly. So they might be a
एंड
sport
फैक्टर
person.
2 ऐसे बोल सकते हैं जो माने एकेडमिशियंस है या फिर आर्ट्स से रिलेटेड
Exactly.
कुछ.
Exactly. So our purpose is to identify this, whether it is from this or not.
अच्छा ओके,
Yes,
फाइन,
yes.
नाउ इट्स क्लियर. ठीक है, थैंक यू.
Thank you. Okay, so that is the second purpose that we have discussed, and to identify the smaller set of salient variables from a larger set to use in a subsequent multivariate analysis. It may be in a multiple linear regression, it may be in a discriminant analysis, or it may be other technique like of machine learning. In that also, like after doing this, after making this reduction, then you can use those data into this this multivariate analysis. Now, some of the important terminology that we should look at, and then we'll perform the factor analysis. The this correlation matrix. So what does it mean? So the correlation matrix is a lower triangle matrix showing the simple correlation, that is R, between all possible pairs of the variable. So let's say variable 1, variable 2, variable 3, and here also variable 1, variable 2, variable 3. So that is what it is showing, the correlation between those variables. The second one, that is communality, or the common information that it is giving you. So communality is the amount of variance a variable shares with all other variable being considered. So it is same, like because it is shared by all other variable. This is also of the proportion of the variance explained by the common factors. Okay, so that is known as a communality. And then eigenvalues. Now, eigenvalues are the the values which represents the total variance explained by each factor. So for factor 1, for factor 2, for factor 3, you'll have the eigenvalues. Now these eigenvalues are nothing but the variance which is explained by them. So in the PCA also we have seen the similar concept, like in that scree plot on y-axis we were having the variance. So that is nothing but your eigenvalues, you can say. And the factor loading. So factor loadings are simple correlation between variable and the factor. Now here correlation matrix is what? Variable to variable correlation, and factor loading means factor to variable correlation है वो दिखाता है. And then factor matrix. So it this matrix contains the factor loading of all the variable on all the factors. So how this one variable is contributing to factor 1, contributing to factor 2, 3, 4. Likewise, it will be showing there. And then scree plot, we already discussed that. Basically, it is the plot of the eigenvalue against the number of factor in order for the extraction. Then KMO measure, that is important one. This is not used in a PCA, but it is used in factor analysis. Now, what this KMO does, so Kaiser-Meyer-Olkin, that is KMO test, that is used for the sampling adequacy. Okay, It is an index used to examine the appropriateness of the factor analysis. So if you perform this and you get this value between 0.5 to 1, then you can say, yes, this is appropriate data for the factor analysis. But if it is, let's say, less than 0.5, then you can say it is not appropriate data for the factor analysis. Now another thing is percentage of the variance. So that is like how, what, the factor 1. So let's say it is 60%. So that is nothing but the percentage of the variance this factor 1 is explaining. And the residuals are nothing but the difference between observed correlation and as which is given as an input to correlation matrix and reproduced correlation. So in a layman language, these residuals are nothing but observed versus, let's say, or you can say actual versus derived value. So the difference between them is said to be a residual. In regression analysis also, that residual concept is that, which is nothing but your predicted value and actual value. The difference between them is a residual. So here also in the same way it is there. Now as I mentioned, that it is difficult to clear the difference of this vector analysis and this one, but although I have found some of the points that I would like to share. So in PCA, we'll mostly focus on maximizing the variance. That means which component is maximum variance explain kar raha hai. So that is what we are aiming in the this principal component analysis. And here we'll be talking about either correlation or the covariance, because it starts with the correlation matrix and all. Here in the PCA, it is not necessary to give names to the identify components, but here in the factor analysis, it is necessary. Otherwise, there is no different, like there is no meaning of doing this factor analysis if we can't find out those common groups name. So that is here necessary. Here in PCA, number of components that we can generate, that is equal to the number of variable. But here in this case, the factors are less than the number of variable. And here in this case, rotation is not possible, but here in this case, rotation is possible, and it is recommended to use to optimize the loading. Now, madam, you were asking that one of my friend, who is also my college friend and social friend. Okay,
Yes.
so in that case, we apply this rotation technique, and we ask him now, like in a layman language, like if we can ask him now, you have to stay either his college friend or you have to be his social friend. So where you want to go? You have only one choice. So he will tell, okay, let me go with the college one because it is enjoyable life. So his loading will move to the that one. So that is what the rotation is. So many of the time, a single variable that might be having the it is contributing in many of the factor. So at that time we ask them, like, either you go this side or that side. You don't confuse us. So that is what the rotation technique is. Now, to perform a factor analysis, there are 6 steps we can perform. So the first is we have to formulate the problem. After that, we have to construct the correlation matrix, and then we have to determine the method of factor analysis, and then we have to determine the number of factors, that kitne factors banane hai, kitne factors ban rahe hai, kitne factors rakhne hai, and then we have to rotate the factors for the optimization. And then we have to interpret those factors कि भाई इसका नाम क्या देंगे, these are the sport people or these are the, let's say, academician or something like that. Okay, now let us try to understand this in detail. So first is formulation of the problem. So it includes several tasks. So first, the objective of the factor analysis should be identify why you are doing this. Now this is practical. Practically, I am facing many of the time some of my clients, they insist me to perform factor analysis on their data. Now if when I ask them like why you want to perform this factor analysis, तो बोलते हैं कि नहीं सर वो आप कर दीजिए ना, वो हमारे गाइड ने बोला है तो करना है. So now this is something like अगर आप करते भी हो तो उससे आपको कुछ as such benefit नहीं होने वाला है. Then why you are wasting your time, money and energy behind performing this task? So first of all, we must have clear objective that why we are performing this one. And like variables which we are including in the factor analysis, that should be specified based on the past research theories or judgment of the researcher or the problem solver. So ऐसा नहीं है कि जितना information मिलता है सबको इसमें डाल दो. It is not like that. First screening is like based on your experience or the research and all, and that you will go with the technique. And it's very important that the variables are measured on an interval or ratio scale. let's say if it is a nominal data or ordinal data, like yes, no, pass, fail, that kind of data is there, then it is difficult to perform this one. So it is very important that it is in a quantitative form. Okay. And a rough guideline, there is no anywhere written, it's like it is rough guideline that there should be at least 4 or 5 times as many observation as there are variable. So let's say there are 5 variable that we are having, then we must collect the data from, let's say 20 to 25 people. Okay, then it is advisable, but it is a rough guideline, so it is preferable. But let's say in some of the cases where we are conducting an experiment, and in that experiment a huge cost is associated with it, at that time we have to take a freedom or take a liberty from this rule. Now here one problem is given, like a researcher wants to determine the underlying benefit of the consumers seek for the purchase of a toothpaste. Now why they are purchasing and what is the intention behind purchase of this toothpaste? So those factors we want to identify. A sample of 30 respondents was interviewed, and using mole intercept interviewing. So in the mole they had taken an interview, and then they collected the responses, and the respondents were asked to indicate their degree of agreement with the following statements using 7-point scaling. So where 1 is strongly disagree, 7 is strongly agree. So what are those? So here this is the data. So V1, V2, V3, V4, V5, and V6. Now what is the interpretation of it? So V1, so we have asked them, it is important to buy a toothpaste that prevents cavity. So in that he will mention that yes, agree, or let's say it is disagree, right? So his preference he will mention basically. V2 is I like toothpaste that gives shiny teeth. Okay. The third one is toothpaste should strengthen your gums. And here you can see this V4, that is I prefer a toothpaste that freshen the breath. And the 5 is prevention of tooth decay is not important. Now see here it is asked in a reverse format. Okay, is not important a benefit offered by toothpaste. So here I'll be disagreeing. No, it is important. So I am disagreeing with this statement. And then V6, the most important consideration is in buying a toothpaste is attractive teeth. So these are the different statements which are formed over here. Now we'll perform our second step, that is construct correlation matrix. Now since we have a less time, so what I'll do, because all the snaps I have taken in this all the codes and everything I have mentioned over here. So if we go in RStudio, then it will take much time because we have less time. And the same file it is there, like toothpaste factor analysis. So here you can see the same file with all the codes and all. So you can run afterwards also. So I'm explaining here, and if it is required, I'll go there. So first of all, we have to construct the correlation matrix. So here for that the function is COR. So any correlation you want to find, you have to give COR command, right? So if I write down the COR and then give DF means in that I have stored the data, right? So and now whatever correlation is coming, so this is creating a correlation matrix, and that I am storing into the CM, that is correlation matrix. This is the name I had given. You can give any name. Now here you can see some of the important aspect, that variable 1 that is having strong correlation with this V3, and it is also having the strong negative correlation with this V5. Okay, likewise you can study like with this variable 2, it is having a strong correlation with this V4 and V6. And likewise you can study all other pairs also, but here how it is like associated with it. So these are the other things. Now here we need to perform this Bartlett test of sphericity. Now what it will tell you, that it will tell you that this correlation that we are getting over here, that is significant. Okay, so as an individual अगर हमें करना है perform, जैसे V1 and V2 का करना है, then we used to perform Pearson correlation test. But this is a matrix, correlation matrix. For that we are identifying that this off diagonal values, these are not zero actually, right? So for that we are performing Bartlett test of sphericity. In that we are getting p value which is less than 0.05, which means we have to reject null hypothesis. That means the correlation is significant. So correlation is significant. It is not zero. That is what we can claim, or we can do with this. Now for this, to perform this Bartlett sphericity test, you need this library which is called REDAS, REDAS, where RE is capital and S is also capital. So that is already there in the script, so you can follow along with that. Now here, what was our null hypothesis? That was variables are uncorrelated and variables are correlated. So here p-value is low, we have to reject this statement and we have to accept this statement. That is, variables are correlated. Now also we have to perform KMO test, that is Kaiser-Meyer-Olkin test, sampling adequacy. And let's say if the value is greater than 0.05, that is desirable here. Now in our case, we have to use this function called KMOS. So KMO sampling adequacy test. You provide your data, it will perform all this activity, and here it is giving you the overall figure as well as it is giving you the variable wise, or the v1, v2, v3 wise, giving you the result. And here it is coming 0.66, which is greater than 0.5. So it is a green signal to go ahead in the factor analysis. Now, before moving ahead, we'll first perform this principal component analysis here, because I'll, after 2-3 slides, I'll explain that why we have used it over here. So for the same data, we use this, here I use this print comp, but you can use PR comp also. So both the methods. So for the variation purpose, I have used this print comp over here. And similarly, you are getting the standard deviation and its proportion of variance and cumulative proportion. So basically from here, what idea we are getting, that how much variation it is explaining. So here you can see these two variables, like two component, not variable but two component, they are explaining 82% of the variation about the entire data set. Okay, so from here I can decide how many factors to be created. So let's say if I I'm okay with this 82%, then I can create only 2 factors. And for that we can also use this biplot command. So biplot into bracket PC. PC means what? Here I have stored that principal component model into this. In last example we have stored this PC underscore car underscore cells. So similarly, in biplot command you can give this, and it will give you like this. So component 1 and component 2. How this variable, like here it is v1, v3 and v5. That is making one group, and this is making another group. Okay, so from here also we can visualize that how these groups are made. Okay, so in component 1, these are having the positive loading, this is having negative loading, and in component 2, this v2, v5, not v5 but v2, v4 and v6, they are having highest loading to component 2. Now if you see, this is the 0, right? So in component 1 they are having 0 loading, but here for the component 2 they are having the positive and significant loading over there. So there are 2 groups it is making, so that we can observe using this biplot. Now if you make the scree plot of the same, then here you can also see, like it is a elbow one, but since one is this kind of point is coming here and another one is coming here, so we may take this two. Now it's totally judgmental. Now here there is no rule of thumb. I'll also discuss about different methods to decide the number of factor, but from here as a researcher I feel that 2 information is sufficient for me, 2 groups will be sufficient for me, so I'll be deciding this. But let's say if it is third one, then you can select this one. Now the third option is determine the method of the factor analysis. Now once this determine that factor analysis is appropriate technique, then we must decide the method of the like how this factor has to be selected. Now there are basic two approaches. So the first one is principal component analysis. So in factor analysis, this is also used like to decide the how this factor will be extracted. And this another one is common factor analysis. Now there are several other approaches also there. If you are using SPSS, in that these options are easily, you can change quickly. So let's say unweighted list squares, generalized list square, then maximum likelihood, alpha method, image factoring. So these are all the other approaches, but mainly these two approaches are used. So here it is focusing on the total variance or variance maximization, and this common factor will focus on the common variance only. So see, practically we don't need to give anything, but we just need to give a logic that okay, we want to use this PCA, and then we can go ahead. So in PCA we have found that only two factors needs to be retrieved. So there we have decided, like using this information, that okay, this two will be there, and this basically here also it is making two groups, so we'll fetch two factor. So to perform the factor analysis, the command is very simple: factanal, right? So factor analysis, so factanal, right? So factanal, and you have to give only your data, that is df, and then you mention the number of factors. Okay, so how many factors you want to retrieve? So I want, let's say, two factors only. And for the scores there are two options actually. One is regression, another one is Bartlett. So that is the backend procedure that it is performing. So do you want do you want to use this Bartlett? So generally this Bartlett logic is used in most of the cases. So we'll give this score is equal to Bartlett, and this whatever output from this command will be there, that will be storing on this FA. Now FA means factor analysis, or the name, any name that you can give, like we had given in a PC. So this is what the uniqueness each variable is explaining. So this variable is 0.06, 0.43, 0.17, 0.37, 0.20, 0.30. Likewise, uniqueness in the variable that has been extracted. And then loading. Okay, now you can see here how this variable 1, it is having full loading on full in the sense maximum loading to this factor 1. And this variable 2, it is having in a factor 2. Here it is in factor 1, here it is in factor 2. And here for this v3, this is 0.89, and here it is very less, it is negative but very less. And for the v4, it is contributing over here. So it is a clear cut indication that variable 1, 3, and let's say 5, they are making one group, and factor variable 2, 4, and 6, they are making another group. And this is another, like when you perform this, at that time this is also you are going to get. So like a sum of squares of loading and this proportion of variance. So this 2 will be able to explain you this much of variation. And test of hypothesis in the backend also, it will give you the result that two factors are sufficient or not. So here it is mentioned that two factors are sufficient. Let's say if you had a large data set and you have just taken a two factor, then it will tell you that no, two factors are not sufficient, you should increase your number of factor. So that is also, this R will give you as a result. Now the question is how to determine the number of factor. Now here we have selected 2.
Sir,
yeah.
Sir, you are saying that the variables are going to the factors, right? But we know that the factor is constructed by the individuals, right? So that means suppose there are 100 individuals, and among the 100 I am creating the factors. So the factors basically consisting of the individuals, not the variables, because if it contains the variables, then how it is capture the individuals? I don't understand that.
So see, here in this case, you'll find both the way. So see, there are few things. One is individual, another one is variables, and another one is factor. Okay. So here it is showing you the loading between this variable and factor. This is what I'm just explaining. And in the further slide, it is also there like this. What is the relationship between this each individual with each factor? Okay, so in the both the way you can see this, and in the subsequent slide I have also covered that.
Okay, sir.
Yeah.
Sir, can we take a 2 minutes break, please?
Yeah, sure.
2 minutes, yes, sir.
Yeah, okay.
Any problem, sir? I am audible. Hello.
Yes, sir, you're audible. Some of the
Yes.
participant asked to take a 2 minutes of break, so that's why I just give them.
Okay, sir.
Yeah,
No problem.
yeah, okay, sir.
Okay, sir. Thank you so much.
Yeah, okay. Now we are starting this. So now, after doing all this exercise, now here as a part of this one, I have already taken here this two factor. But let's say the question is, how can we decide the number of factors? So there are several ways or the procedure that is suggested to determine the factors. So these are all this procedure. The first thing is a priori determination. Like if you are as a researcher, you decide that भले ही वेरिएबल 50 है लेकिन उसमें से मुझे 3 में ही ग्रुपिंग इसका करना है. So that is, and now it may be based on your experience, it may be on the past research, or let's say any material or the review of literature that you conducted. So that is called a priori matrix, and that you can fix that, okay, this much of variable I only this much of factors I want, so that you enter in that analysis. Another one is eigenvalues. So if let's say eigenvalues are greater than 1, that means you should take those variables. Now here you can see eigenvalues are nothing but the variance. So for this one, this is, let's say you consider this as an eigenvalue, because eigenvalue and variance are equal here. So for component 1, the eigenvalue will be, let's say, around 2.7 or something like that, because it is going beyond that. For this, it would be, let's say, 2.2 or something like that. For this third one, it is 0.5. It is not greater than 1, so we can select only this 2 1. Okay. Now another thing is, the third logic you can have is based on the scree plot, the same thing we discussed, right? So based on the scree plot also, you can find out that elbow point where it is coming, and you can also go with the based on the percentage of variance. Like you decide that, okay, 90% variation I need after performing this one, so that you select that how many components are there or how many factors are there which are covering 90% of the variation. So up to that level you can carry out. Based on the split half reliability, so many of the time this if we are dealing with the large data, this entire data is splitted in a half one, or in both this set of data, the part 1 and part 2, in both these cases, this factor analysis is performed, and then only common factors in which in both the cases, like high loading is coming, that will be only retained and other will be excluded. And there are several statistical tests also there that you can perform on the identified factors, and then you can decide if it is statistically significant, then you should keep those as a factor, otherwise you should not keep. So these are the 6 different methods which is given in the book called Marketing Research by Naresh Malhotra. That is very good book. Many of the examples I taken from there only. So in the last slide I also shared the references. So for more details, you can go into their detail also. So here it is the scree plot. So we can decide like the two, like eigenvalues greater than 1, that I would like to have as a factor. So this will be the 2 factors. Now we need to rotate this factor. Now in R, by default it is giving you the rotated one. So it is by default rotation is done. So here it is not the case, but let me show you how it is confusing you. Now here, let's say before rotation, this V1, V2, V3, V4, V6, up to V6, it is there. Now these are the, it's loading to these factors. Now here the confusion will be created at this point of time, because it is sharing in, both the factor. It is sharing his loading in both the factor. and basically it is a like situation where we are losing our information, because here also somewhat there, here also somewhat there. So we many times confuse that, to keep it in a factor 1 or factor 2. But if you rotate this one, that is, you just change the direction of it. I'll also show that one. So after rotation, it will be either move either this side or that side. Okay. Now let us see the practical example. Since in R automatically it is done, so this is not the snap of R, but this is the snap of SPSS. And in the same example it is done. So let's say before rotation, how it was behaving. So V3 is having this much of here and this much here. Okay, likewise it is given there. Now here it may have a confusion, here it may have a confusion, because both the side it is high. But if you rotate the same thing, now you can see, for this V1 previously how much it was. It was 0.92. Here it is 0.96, and against that it is very low. Okay, so it has forced that my friend, that either you be a college friend or you be a social friend. So he has decided his way. Okay, but let me go to this side. Okay, so now you can clearly see this one, like this V1 and V3 and this V5, they are making a one group, and here these three are making another group. Now there are many types of rotations, like one is orthogonal rotation, another one is oblique rotation. Now in what do we mean by the orthogonal rotation? So the rotation of the factors in which the axes are maintained at the right angle. So it will move from left to right, and right angle axes are maintained as it is, and it minimizes the number of variables with high loading on a factor, thereby enhancing the interpretability of the factor. And then Varimax is very popular method. So in orthogonal, there is one method called Varimax method, variance maximization, and that is popular technique for the rotation, and it will give you the optimum result. Now in oblique method, it is quite opposite of it. So here right angle is maintained for the axis. Here it is not maintained. That is only the difference between these two. Now, what do we mean by the orthogonal and oblique rotation? So see, this is the case of orthogonal one, and this is the case of oblique one. So here this right angle axis are maintained, and it is moving from this. This is original one. From there it is moving to this side. Okay, and it will always make a this kind of plus sign over there. Okay, so it will move together. Now here you can see it is not maintaining this axis. It is as it is, and you are just moving this one, and you can move this one. So it may not make a perfect square one. It may go in any this one. That is oblique rotation. Now the last part of it, like after after getting these loadings, after getting this yes, where it is, yeah, this loadings, we need to interpret this factor, like what to call it. Right. So let me just focus on that part. Okay, so here you can see the loadings are given with reference to the factor in the variable. Now V1, what is that? So the description of the V1 is, it is important to buy a toothpaste that prevents the cavities. V2, okay, that is, I like toothpaste that gives shiny teeth. A toothpaste should strengthen your gums. V4, that is, I prefer a toothpaste that freshen the breath. And V5, prevention of the tooth decay is not important benefit of offered toothpaste. Now here you can see this is in a negative direction, it is asked. So its loading is also negative, you can see. And the V6, the most important consideration in buying the toothpaste is attractive teeth. Now here you can see, this color. Now, can you find out any pattern between these two groups? Can anyone? Can
Yes,
anyone
sir.
find any pattern? Yes.
Basically, yeah, sir. These are the customers who are basically preferring the toothpaste for the quality of it, uh, not the outside of it, because these are basically related to the qualities, right? That whether it is prevent cavities or not. or whether
Right,
it
right,
is
right.
strengthen your jumps or not. So these type of qualities they are talking about. They're not talking about the what whether it is attractive or not, like that.
Correct, correct. Yes, very correct. So let us give a proper name to it. So let's say these three are, making like one group, that is shiny teeth, fresh breath, and attractive teeth. So you can say it is, kind of a social benefit factor, like social benefit in the sense attractiveness, and then, this fresh breath, and then shininess, and that kind of aesthetic point of view they are looking at it. But if you look at this first three one, that is prevention of cavities, strong jumps, and this prevention of tooth decay, they are more relevant to the health benefit factor. So actually underlying two factors are there. One is health benefit factor and another one is social benefit factor. And this is, basically the interpretation of this factor analysis. Now, as a company, what do I infer from this one? So after this, what will be my action? So there, this marketing strategy, then design strategy, everything will be aligned. So nowadays you can see, ये toothpaste लीजिए, इसमें ये है. It is special for the sensitivity. This is for, let's say, in case of shampoo, this kind of survey might be done, and some of the people, they have found that some of the people focus on hair fall, some of the people focus on the dandruff, some of the people, focus on the, let's say, long hair. So they identified the group, and then accordingly they design a product for the different segments of the customer. So that is how it can be done using this factor analysis. Now this is already we had discussed. So PCA is a linear combination of variable, whereas this factor analysis is a measure of model of a latent variable. And this is the reference. So these are the two books, very, very good book. If you are a researcher, then you should have this book, Marketing Research by N.K. Malhotra, and Multivariate Analysis and its Application by K.C. Bhuyan. And these are the different links from where I taken some of the theories and examples. Now, one question was there that I think I had covered in this snap of it, but let me show you quickly that how it is related with the variables. So toothpaste factor analysis. I'll quickly, run this one. So here variable to variable correlation is there, and there it is rotation matrix. Yes, score. So that is with reference to the individual. So here we have 30 observations. So here it is, the first, second, up to 30 observations are there, and how it is, associated with this factor 1 and factor 2. So there are actually three terminology. One is individual, that is this one. Another one is variable, that is we just seen in the this previous one. This one, variable with the factor, and there is a third one which is factor with this individual. So this model will have so many attributes. So if you look at these attributes of FA, then see 13, 14 of this different information it is having. So you can explore this one if you want to know more in detail, and this links also will be useful to you. Yeah, if you have any query, then please we can discuss that. If you don't have any query, then please mention no query in the chat box. I think everyone has. Yeah. Thank you, madam.
I think that most of the participants understand the things
Yes.
because you have elaborately discussed the issues, different issues. So thank you, sir.
Thank you so much, sir.
So I thank on my university. Hope we will get back to you in within a couple of months for next workshop.
Sure, sir.
Okay.
Thank you so much, sir.
Thank you, madam. In case of any
Okay.
query in future, you can reach out.
With the next resource person.
Yeah.
Okay, sir.
Yeah.
Hello.
Yeah.
Okay, sir.
Thank you.